Yeah, I'm just listening. Down on the first floor or second floor? I'm over at Rover. Okay.
Just like yesterday, anybody, we need everybody to sign in back there. Just put your name, check off your name. If you want to do it now, just do it the next break. That's fine. Need parking, see Daniel as well. And we'll wait 3 more minutes, and then I'll let Gilmer start. Any questions, Sean?
Will this material be public after the course?
Yes, I keep it forever. Let's say I have the previous year has been there, the year before has been there, so you can see, and you can later you can watch the videos on YouTube. They will be posted publicly. All those things we make public, and it's okay. And they have been used also for people, even in some other countries, they use it for teaching friends of mine in other countries. Okay. Okay, last question. How many of you are familiar with the idea of software containers, or the idea of Docker or something like that? Sounds something around. Okay. This is what we will talk about today. How many of you are familiar with the idea of virtual machines, this concept of virtual machines? Okay. Those are related, but not the same thing. So a virtual machine is a piece of software that emulates a computer. So it's actually emulating all the different pieces of a computer with software. A container is something like that, except that it's not emulating the computer itself, it's just emulating a file system structure, and it's containing that file system structure in such a way that you can have a file system that mimics or behaves like a different Linux distribution and different version from the host machine. And there are several reasons for using such things. One is that with this, you can work in some ideas that had been floating around in the research community that is called reproducible research, where all the procedures that you have done to achieve a result on a paper can be reproducible by somebody else somehow. That is the idea of offering transparency, or offering the ability for actually review what you have done, which is in practice kind of hard to reproduce others people research. You don't have the time to do the whole simulations again, and you have to at some point research. It's a big bunch of trust each other. So if something makes sense and it's not too crazy, okay, we can trust this, we can trust this, we can trust this. If it's outstandingly difficult to believe, okay, you ask for good proofs of good. But anyway, so this idea of reproducible research, people came up with this solution somehow, that you can create containerized version of a computer or the file system with that all the software and all the packages, such that you can reproduce the same simulations or same procedures on a different machine, and you should be able to get exactly the same results. Also, from the industry perspective, that helps companies, institutions, for example, WVU, to containerize small pieces of software and keep them separately from a big machine. So you just want a web server, you have a web server, something goes bad, you remove that, you put a new instance, and you work with that. So managing that in small compartments. So the most popular product for that, for containers, is Docker. So that's why I asked you. It's not the only one, but when people think about that, this is the probably most prominent solution for this kind of things, Docker containers. There is just one problem, a big problem with Docker containers in the HPC environment, in high performance computing. And it's basically that to use those containers, you need root access. You need super user capabilities in order to run those things. Something that we cannot offer. We cannot offer on a cluster, giving the people that access, that level of access in order to run in containers. But there is an alternative, there is a solution to that has been developed, and it's called Singularity. Singularity is very similar to Docker. Actually, you can convert Docker images into, or those layers into Singularity images. That's exactly what we'll do today. That allows us to package software that otherwise force us to install a lot of graphic user interface libraries, and we have to do that on every single compute node on the cluster. Is a pain. And for things that not everyone wants to use. So for that reason, we offer those Singularity containers for certain kind of software, especially software that bring us a lot of dependencies with graphic user interface. So a lot of dependencies with GTK, Qt, all that stuff for making buttons, making text boxes, all this stuff. The amount of the dependencies is huge on that. Or for software for which we cannot install it on Red Hat, because the Red Hat that we have on Spruce is too old for some packages. They demand more recent versions, or they were prepared for Ubuntu and they don't have any equivalent for Red Hat machines. So we have to use the Singularity images that mimics Ubuntu or Debian environment in order to install that software easily. One case is, for example, TensorFlow, but right now we can offer that TensorFlow in another ways. But this is one particular case where they have packages for Debian, and it's very easy to install in Debian, or a very recent version of Red Hat, but not Red Hat 6 point something. So let's start with that. We will talk about that, how we use it. And I strongly suggest, if you have the ability right now to work with this mobile extern, to use it, because from what we heard today, this is probably what you want to see with Windows popping on the screen. What?
Make sure that's Windows only. Mac or
if you have Mac, you would need to install the Xworks, the X11 server for Mac. That's the only thing. But if you are using Windows, if you are using these kind of machines, and you have mobile, if you have the ability to install something like this, go for it. That's what I will use right now. So check that that you can. Oh yeah, okay. Then you have this thing that you are able to create windows out of that. Check the text clock if you like. That you are able to get windows popping on your screen. So that's the first thing. The first thing that we will do is connect into Spruce. If you are using Linux or you are using Mac OS, this is the way you want to do it. Eventually, if you are remotely attending this, there is an extra command here, an extra argument, -C. It's something like this. In addition to that, it's like this.
I couldn't get it to work unless I use -Y instead of dash.
Yeah, and sometimes the only thing that actually works is that uppercase Y. So that's another thing. And the C enables compression. And as I will show you a little bit of things that open complex graphic user interface, it could be slow if you are not connected through a physical network cabling on campus or things like that. So with this, you will accelerate a little bit the transfer, compressing. So you can see a little bit of this. That's unfortunately penalty of whatever you want to use with graphic user interface is that it's slow. It's always slow compared with just the command line interface. That's the first thing. So now we will do something different. I will execute this slightly different on what I'm screen here. I will use the training. So with this command, I will ask for getting one. Let me see. Let's add complexity to this. No equal to 1. Ppn equal. Let's say I add a little bit of more things. Let me do this. So you get this on the very top of this. Right now, I am asking. So let's explain this. Let's explain this. QSub is the command that we saw yesterday for submitting jobs, for asking for a job. This uppercase X is because I would like to have a graphic user interface. Transfer, so tunneling that up to my computer. This I is because I would like to have an interactive session. So instead of yesterday that we just submit a job and we wait until the job is done, this time I would like to get a computer for me right now to use it right now under my terms. So this is the command for doing that. This is the closest to actually getting a good desktop right away for you to use for a certain amount of time. I think the default is a week. If I put here standby, we'll be getting a machine for 4 hours. I'm asking for one node. I just need one machine, and I am taking 4 cores of that machine. Imagine that I would like to. That I know that the code that I will be using, if it's Python or R, I am able to parallelize, so I am able to use multiple cores on that and take advantage of that. Remember that parallelization is not for free. It's not something magically appearing in the code. You have to work a little bit to achieve that, to take advantage of parallelization. And here I am deciding that I would like to use our training queue because we have some priority on that. So yes.
So like if we all submit this, all of us will use 4.
All of you will get, for example, we have machines with 16 cores. So on that queue, right? Machines with 16 cores, and I'm asking for 4. So I will get one machine and use 4 cores. Another one of you will get exactly the same machine and will get 4 cores. Another of you will also get exactly the same machine and use another 4, another. So four of us will get into the same machine. And we will share the entire number of cores between we 4. At that moment, Nate, how many machines do you have for training? 6. So how many people is attending today? Online. How many? 10. So yeah, probably we are right. We're okay. So we, all of us, we will have enough cores for everybody here. Then. So otherwise, someone will be behind him forever. And so I will execute this. Well, it typically is not that fast. It takes up to 2 minutes. There is a cycle. So the daemon that is running on the node that is collecting that, and it is not permanently doing that. So it takes like 2 or 3 minutes just to do that. And after you get in queue. So if you wait 5 minutes, usually it's okay. But I got it. I got it right away. It's kind of amazing, but yeah, okay. So again, this is what you have to do if you want to use Singularity containers. I have a module. We have a module. We talked about that yesterday. To load to enable us the ability to use containers. So module load Singularity. You can use tab. You can complete. I suggest to use the 5252. Daniel or Nate, choose some. And you execute this. So now you are able. The Singularity command is there for you. Okay. So let's start with Python, because I can offer a couple of things. So the command for that, all the commands for Singularity is Singularity, just that. So you use this command Singularity. They have several subcommands associated. Most of the time, all that you want to do is execute the shell command. So get into a machine. And another command that you can eventually use if you are using this for running a non-interactive executions or things like that is Singularity exec, and then on the location of the image and script. We will not talk about that.
I don't understand why what are we creating a Singularity container? That's it.
We will be using one container that I prepared for you, and I have several. So I will show you which they are. So I have several. I will show you exactly. We can start digging into this software, share software containers. Let me see. Before doing this, let me show you what we have there. We have a collection of images for a variety of software for which my best solution was opening Singularity container, because we cannot run it on Red Hat 6 because it uses too many libraries, and for some reason I offered that solution for that user via Singularity containers. So in particular, I will use this one. This is called the Jupyter's Signal. It's an image of Ubuntu. So it looks like an Ubuntu machine with all the niceties, all the particularities on Ubuntu, and it will be running on a Red Hat box. For people who is familiar with machine learning, especially neural networks, I have this one that is the official. I don't know if this is the official or not. No, probably this is not the non-official. This is one that is attached with Keras for those who are familiar with these kind of things. There is another one here that I will show you today for our studio, because at least one person here mentioned that, or one or two of you mentioned that are familiar with R somehow. This one is for genomics, for population genomics, if you, some of you are into that. Those are the, I think those are the official ones, yeah. For TensorFlow, with Jupyter attached, with GPUs enabled on them, and Python 3. Visit is a code for visualization, 3D visualization of large amount of data. And I don't remember who was for this thing, so I offer that. So right away, we will focus on this one and this one. And here you see this one that ends with SIMG. Those are the images. So it's one file that contains the entire operating system, the file system of a different Linux distribution, with software installed, packages, even data sometimes included in that image.
Your home directory?
It's just a file. So what?
Your home folder will be the same?
It contains, no, it will link to your home folder. You will see that you are able to see your own files and everything on that system. But the root and all the libraries locations are internal to that. So are completely detached from the underlying, from the host file system. So and here, those BST files, for those who are interested, contain the recipe. So, and I will probably show this today, the recipe for creating that image. So if you are interested in using one image, but you would like to have this and this and that, you can use my recipe, recreate your own image, and move it to the cluster and use your image. I really don't care. So you can personalize it. You can create your own image, and I will show you that, how that. The only thing is that you cannot create the image on the cluster. You have to create the image on your machine because you need root access for the creation of images. Not for the usage, but for the creation, you need root access. So, I will use right now Singularity, Shell, and I will use this one, Jupyter, Xenial, SIMG. So let me put this at the very top here. This is a command. Oh, I got it. Oh, it's good. Okay. So I am declaring that I would like to use this image.
Hey, Gary, real quick, show everybody how to download the extra.
Oh, yeah.
Go through the whole process.
Here is the web page for downloading the mobile external. There is here a mobile external, the Pro Portable Edition. When you do that, you get on your downloads here this zip file. You uncompress the zip file, and you get this folder with this mobile external personal blah blah blah, and this is what you execute. And this one is an SSH client, so allow you to connect to a remote machine attached to an X11 server, so a Windows server from Unix environments, such that you can get Windows from Unix into your Windows machine. So that's the, and I would like you to be on, if it's possible, to use this one in order to get the windows that we will pop up with the Singularity. So how many of you are in to got this running? Please raise your hand if this is running for you. So it's running for you. You have troubles there with that? With the Movexter?
Yeah,
It's not working for you?
it's on Mac.
We're on Mac.
Ah, you're on Mac, so you don't need it. You don't need it. Okay. So you don't need it either. You don't need it, but you have X-Squares. You're right. You have X-Squares on your machine. You know. So there is something for Mac users. Let me point you to Mac X. There is this software called X-Quartz. So if you are on a Mac, this is what you need, X-Quartz. Because again, Mac is not Linux. They have nothing to do with Linux. Mac OS comes from a different distribution of Unix called BSD long ago. So they depart from many years ago from the Linux environment, and they use a different kernel. It's a completely different story behind Mac OS. So you need this software, otherwise you will not get Windows popping on your computer. And so it's not big, and it's good to have it just in case, and it will just run when you need it, and so it will not consume your computer with garbage, something like that. So Windows users, try to use this. Mac users, all that you need is this, X-Quartz. We can go back here. And I hope you are on this line. That you, how many of you have lost in this? And so I repeat the whole procedure if you like. How many of you are lost? You are lost. Okay, I will go back and repeat the whole thing. So even I will go back here. So I just connect to the cluster. You see that my prompt, it's right here. I am training 001, and the head node, the machine where I land when I go into the cluster is this SRIH0001. This is my first machine, the landing machine. So the first thing that I did was this command. Oh wait, it's right here. So let me point here. Is this command? So this was my first command. I execute this command from the head node, from this landing machine. What I'm doing in that line is asking for getting a job with graphic user interface tunneling up to my computer with an interactive session. So I need a machine right now for using it to a certain amount of time. I will not work with JavaScripts or anything like that. I just need a machine. I need to work on that right now. I was having a desktop on my own for me. And this is a small nicety. I'm asking for 4 cores on that machine. On one single machine, and I'm using this queue training. Remember, queues are different lanes, and those lanes offer different capabilities in terms of how long the jobs should last. So that we have a week, we have a day, we have the standby that is 4 hours, we have a debug queue that is 15 minutes, and we have training. Those are a set of machines, 6 machines that have been separated from the cluster just for you, so you got access to them. I will actually reduce a little bit my own demands. I will just ask processors, just 4. But if you want to use 4, it's okay. Try not to use 6, 8, because we will screw in somebody else, and we don't want that. So you execute this. Typically, you wait a couple of minutes to get a machine, and you know that you got a different machine because the program changes. The name of the machine changes, and you get a entirely different machine every. Well, you can get a different machine every time that you submit it.
You can request a specific machine.
You can request a specific machine. The problem with that, you can request a specific machine, or you can request a specific type of machine. So remember that on Spruce we have, you can wait forever. If that machine has been in use and somebody requests that machine for 1 day or someone, and that machine has been separated for some reason, you can sit there forever. And so it's a much better solution if you want, for example, I have my code and I optimize my code for Broadwell machine. I would like to take advantage. I don't want to get IB, Haswell, all machine. I want the latest machine on Spruce. It's Broadwell. So you can specify that you just want Broadwell machine. We have a collection of them, and just will use that machine. In that case, the command is something I don't want to change it. You put here column and put Broadwell, and you get a Broadwell machine. You set Haswell, and you get that IB. So you notice that I got a different machine now. This machine right there is different from this one. It's a different machine. This is what is called a compute node, right? So we are there. If you check module list, no modules I have right now on that machine. If I try to execute Singularity, Singularity doesn't exist. I cannot do it. I need Singularity. I will show you Singularity. That's the purpose of this morning. So I need to module load Singularity this. I need to execute this line. So try to execute this line. If everything is okay, you see nothing. That's good. You execute that module load Singularity 2.5. Okay. So now the command Singularity is there. The subcommand that we would like to use is this one, Singularity shell. And the name of the image is right here. All my images are here in software, containers, all of them are there. All the images, yes?
So can we submit these even we are still waiting?
No, you wait until you get this prompt, this prompt here. Typically, it's just a couple of minutes, but at some moment you will get something like this that is different from this. So you realize that you are on a different machine. You got a compute node for you at that moment. So, and you declare the number of cores that you would like. So if you, for real, not right now, but later when you have an account, your accounts, and imagine that you are using something that is able to take advantage of 16 cores, you can request the 16 cores. I want an entire machine for me because I can take advantage of that. I need a good workstation right now. You request the 16 cores, and you will get it.
How many nodes we have in Spruce?
We have, how many nodes in Spruce? 100 something? 170. Yeah, something. Yeah. So, and you will get one of those. On Spruce, we have nodes with 16 cores. The Ivy Bridge are 16. The Sandy Bridge, that are older, so it's lower, but they have 32 cores on them. Haswell machines have 24 cores, no, 20 cores, I think. And the Broadwell machines have, they have 24 cores. And on the new cluster, The normal compute nodes all are Skylakes with 40 cores each. 40 cores each. And the GPU nodes, we have 6 or 7 GPU nodes. Those GPU nodes has 24 cores, but they are also Skylake. So they are very recent processors with AVX 512 with extensions. They perform, sometimes they perform, have double the performance of this of a machine like this. So Jupyter, Xenial, SIMG. This is the name of the image that I would like to use. Now you will notice something else when I execute this. My prompt changes again. Now this time it's like this. For most practical purposes, I am on an entirely different machine. So this machine is not longer a Red Hat. Doesn't look like a Red Hat machine. It's actually, you can see that this machine actually has apt get the typical command to install packages on an Ubuntu machine. So this is like running on an Ubuntu machine. That's one thing.
Yes, the users on this machine.
What?
Yes, administrator.
You are not administrator. You don't have abilities, and the machine is immutable. These images cannot change, so you cannot install packages. If you like, and I will show you, you can create your own image with your packages, create your own, and transfer that into a Spruce and run your own images on your package. But you have to create that image on your computer. You cannot do it on Spruce.
Basically, this gives you a way to have admin access. You have to do it in the workstation, just like you normally do. So you log in workstation with root, whatever you want to install. You upload the image. Once it's up there, though, it can't change. The good thing about it is it doesn't change. So you take this image and then you go to another school and you want to run it there, you should get the exact same results.
That's another thing. Yeah, you can take that image. You can create your own image when your packages, even with your data. Imagine, for example, you have your database, and you put that database. The database, if you are comfortable with that, making the image 2 or 3 gigabytes bigger, is okay, but let's say you can have your data attached with the image, and you can run it on a Spruce, run it on Thorny, go into a supercomputing facility in Pittsburgh, Texas, the West Coast, or wherever, and run it there, and it should run identical. So that's the nice thing. So you got this, and you are like a different machine. You can check, for example, that the Python version that I'm using is this one. This is the Python, so they have probably the Python 3 version here. That's what we actually want to use. And I will show you, for example, a small example with very simple graphic user interface that I like a lot for these kind of things. So you execute this one. And you saw a window popping on your computer. If this is working for you, we are on the same track. You should get a window popping, this window. I will see if I can make this bigger, but I'm not. Okay, Control plus. Let me see if I can make this bigger, because I can allow me to show you something. So I will make bigger, Control plus, Control. Okay, that's slightly bigger. Okay, so I am in a Python environment. We're using this is IPython, and I will be using this for creating a plot right here. So if you don't know and you are not interested in Python, just follow this as a recipe. Wait, probably this is just a word. I'm executing, I'm importing a couple of modules, packages from Python, for those of you who are familiar with that. And I will create an image. No, but what I did should be. Okay, this was my mistake. I should have been using this magic for IPython. So this is not Python, this is IPython, and this is Python. So basically, I would like to do this. This is plt.plot. Okay, a very simple thing. Basically, using this image to get a Python environment where I execute IPython with a Qt console. This is what's called Qt console, that allow me to execute commands and make plots and see those plots directly on my screen, so I can play with my data and get some insights, so I explore what is in my data, making some plots and play with that. Later, I can, with this magic, I can store all that information in a file, so I can later reconvert this exploration into a script, and later tweak that script for getting publication-ready images, plots for journal, for my paper. So, and get this as a collection. This is a way of working interactively first and non-interactively later, to get research moving for me in the most efficient way possible. So this is the Qt console. This is one way. I will show you quickly another. Let me see. I exit from that window. What?
Control Q.
Yeah, I think, or close the window, or I just tapped, I exit. There are some ways. I really don't care about. There is another one. And I would like to not.
Hey, you're me a question in the chat.
Let me see.
I'll show you how to bring it. I read it to you, but it's more
What is this?
don't close that. You're at the very top of there.
Chat.
That. Yeah, just put that over there for you.
Okay.
You just leave that up. Me and Dave will try to answer some of them I can, because I don't remember exactly where it's at.
So when I type Singularity Shell, when I type Singularity Shell, Jupyter, not Jupyter, it's Jupyter Xenial. Try and well, no, that's not okay. That issue is mostly this MobaX term. That if you change for some reason the size of the window, it's not properly creating the new line, and it's just overwriting the line, is making a little bit of a mess. So try to create the terminal with a size and try to not change it or not expand otherwise, if it's not able to figure it out, that the window have resize somehow, but that creates confusion. That's why I reset and do it again, so I could get that.
I think you're good.
Yeah. So I hope that you got what is happening, but nothing is wrong. It's not related to the spruce or the compute node. It's just mobile external that is not smart enough to realize changes on the screen. Okay, so this is another one. Let me see if I can get it working. They're really nice. This is called the IPython notebook. At that time, I'm using a relatively old image of Ubuntu, because I have some constraints also with which images I can use on Red Hat 6. So this is called IPython notebook. Nowadays, it's called Jupyter notebooks. They detach from the original IPython project. So this is a separate project, and it's called Jupyter. And they now support different languages. So you can work with R, Julia, Python, of course, and probably they have Ruby on Rails. They have a bunch of different languages. So it's not attached to a single language. It's just an environment for interactive computing. So basically what I would like to do here is to create a new notebook. So again, this is like a research notebook, and I pretty much will do exactly the same commands that I executed before. Matplotlib inline. And this time, in order to execute the command, is a little bit like MATLAB. Shift Enter. The Enter just makes a new line. Shift Enter actually executes this command. I will import a couple of things, the same thing. I will exactly do it. Maybe. I never tried this.
Also shift. Create another line.
No, Shift Enter to execute the line that you right now.
Control shift.
Oh. Let me see. Maybe useful. Okay. Well, okay. A little bit bigger. So import NumPy as NP. Import my. Another thing is that you can complete commands with a graphic user interface. It is really good. You see, I will use Pipla as PLT, and I will execute Shift Enter, and I execute this box of commands, and now I will PLT plot MP random rand dot rand, and let's see 100 points. This time I would like to get them red with circles. I changed a little bit just to see them. So I Shift Enter, execute that, and I got those random points on my screen. So again, for executing commands on the system is really nice. Sometimes you can search for IPython notebooks or Jupyter notebooks. They have online, people have posted trainings, tutorials on signal processing, on natural language, on a bunch of stuff for training people, so they can execute these kind of things line by line and understanding what integration does, what differentiation is, when you are doing machine learning, what linear algebra, all this stuff, and people is executing this line by line. You ask people to change a few places so they can explore what changes when you are executing this. So this is a nice way, not only for working on research, but eventually also for teaching materials. Could be a nice interactive way of teaching. But right now, what I would like to show is that with Singularity, and I'm able to offer you a software that could not offer you otherwise due to the dependencies. I will have, in order to have this, I have to install Firefox on every single compute node, and we don't want to do that. So with the singularity, that image contains Firefox, contains Jupyter, contains Python, a recent version of Python, and I can pack that in a single file. And I can move this file to a different computer. I can move this file to your computer. If you run Linux or you have a virtual machine with Linux somehow, and you can execute this and you get exactly the same environment. So this is a really good one.
Looks like this machine is not connected to the internet.
No, compute nodes are not connected to internet. That's a good point. Compute nodes have not internet connection. If you need data or you need to download things, you have to do it in advance out of your interactive session. So from the head node, you download everything you need. If you need tables, you need files, whatever, you have to download it first and get into interactive session to work with them. Yes, that's actually a good one. Let me show you another image, and we move into something else. Here you have to execute Control-C because the kernel is still running, and it will ask you if you want to shut down the kernel, the server, and you say yes. So you get this. Now I will leave. Remember, right now I am inside this singularity, this image, and I would like to leave this image. Is just exit. I exit. I am still on my compute node, the compute node that I got for my interacting session, but I'm no longer using that image. And it's something that also you can do. You can execute something with one image that contains something. Later you want to move to a different image that contains a different language or different procedure or different software. Execute that, jump into images and execute cascades of executions. So let's use another one that I have here. There's the RStudio 1. That is 1.44. Yeah, this one. It's RStudio Desktop 1.1 using R344. Right? So singularity, shell, and the location of the image. Enter. You notice again the prompt have changed. A different prompt here. I am, for all purposes, I don't know which this image, what it is. Yes, this one is a Red Hat machine, actually. They have Yum. Probably not actually Red Hat, it's a CentOS machine. So you can actually see what this machine Red Hat is. Yeah, this is a CentOS 7.4. So again, we are running on top of a Red Hat 6.10. And we have RStudio here. So you can execute this RStudio. Again, if your session requires data, you are processing something, you need to do it in advance. And you cannot install packages, well, for the same reason, basically, because you cannot download packages from internet, so you have to do it somehow from another place. But so to say, you can execute things here. You can, if you know this R, you can create variables, you can play with them, you can make plots. You have a RStudio, and if you request, and for example, if you know how to work with parallel R, with the routines that parallelizes R, take advantage of multi-cores, you request a machine with 16 cores, and you process your data in parallel using those 16 cores.
Back to black screen. I did not have time.
Okay, I will close it and I will do it again.
Just the RStudio code, those details, those numbers there.
Okay, this is the command. Probably, are you here?
Yeah, I was typing that when you.
Okay, so so I will talk a little bit. Yeah, okay. So that's the command to get access into the software that is installed on that image. unfortunately, this is another example of the kind of software that we cannot offer directly without using Singularity images, because our studio, except for a very old version, I think, it's not compatible with Red Hat 6 anymore. So they need a recent version of Red Hat, and changing the version of Red Hat on a cluster with 160 something nodes is a real pain. So
So, a question, like when I'm typing that long thing, that
Yes.
whole string, it doesn't allow me,
it should pass to the next line. Sometimes the terminal makes a mess.
I think overrides kind of the beginning of
Yes, it's probably because you resize the window at some point.
well, I had to. So I
Yeah,
thought it
so
was
let's
like-
try. I would do it. For yours. Okay. You know this. Yes, it's like here, so it would be a variable. Yes. I think I did it right. What I did was kind of a trick. I created a variable with this long string, so I can use this. And not having this line my way. But now you are in. It's because at some point you probably resize the screen or change something, and mobile external is having issues. Resize. It's not your fault. It's not anything on exposed. It's like this text. On mine that works. No, on yours is mixing somehow the lines. Is send you back at the beginning and not putting in the right position. It's making a mess. It's unfortunate. So right now, execute this. No, MATLAB is goes away. There is a module for MATLAB, and you can use MATLAB. Right? It's taking a little bit, but eventually you should get it. Okay.
One point about MATLAB is it's free for you guys to use, but there's some costs provided for you, just like costs. So there's the cost you guys use. No cost. Like college might make you pay for it. Every course. Something's already something.
Oh, yeah.
Or you are trying to execute directly.
I think it's static covers it, but I don't think it does.
Okay, let's see. You execute something. Okay, something.
They help with the cost this year.
Yeah, 2012. That's what it are. Right. Q sub minus x minus I and Q minus Q. Okay. Now it's working. Now. This is your machine, right? You need to execute this with this. And if you want a little bit of compression, with this. Do you want this a little bit bigger?
So we haven't fixed this for the.
No, for you to see
At the same point.
So yeah, I'm not able to also this. Yeah, exactly. So the Y, the uppercase Y, give you an ability to export windows. You install the export, right? Okay, you have export. So type that, right? Go type. And type the password. So, and I will be with you in a minute. So you see here, you have our studio, and it's the same thing for other images. And some of them you have the software for that area, for that specific type of research. Okay. Who got this? Where are you? You are. Are you on a spruce? Okay. You are on spruce. You are on spruce. Okay. Now, this one. What was the see? I don't forget about the comment. I just make this for you to copy that. Okay, but not the comment. So okay, okay. So for example, like you I show you all the commands that start with us. Let's say you go here. Let's say I want to see all the commands that start with the something. I will show. Okay, there are more than 500 commands with me. Let's see. No, so not with yes. See. There are several ways. I showed you yesterday. So that will show, and you go until you reach the point where there is ambiguity. There are several commands. So you fill all the line up to reach the point where there is ambiguity, and you put another letter. You tap. I hit that all the time, and I improve it, and so. Now I can go here. Now we can. I would like to go to the very beginning of the line. So Control A. This. I just hit this command, and I execute this. Are you able to execute this? Yes. Yeah. This okay. Now when I register, yes. Does. And it cannot be loaded. Yeah. So leave. Exit. Go exit. And the next time that you enter what? Something else. Okay. This uppercase that. That's this. Yes, exactly. The problem with our studio, when you just start, it tries to connect to the server to see if there are updates or things like that. But the compute nodes have no internet access. So they will send you a message here that it tried to connect to the mirror, but it could not connect. So I don't know if there is something wrong with the connection. This message all the time that you connect from the computer. But the only machine that can do something is the head node.
So like all of the entire arts.
Therefore, no, for art to run, you don't need internet connection. You need internet connection in two situations from the outer space. If you need to install packages, they are downloaded from internet, install package, blah, blah. You need internet connection to download the package, install it. And you can do that from the head node if you like. And you can do it as user, and you can install your package as user. So it will be in one location on your home folder. So you can install packages. Nothing prevents you to do that, but you have to do it from the head node. But the first machine that you cannot do the interactive. Another situation is when you need data. So if you are downloading data from I will show to during the Python thing something from data from the census, from the data for the population of the United States, all the stuff. So I have to download those Excel files in advance in order to operate with them. I cannot do it from the computer node because not internet connection again. I will not be able to download them. So that's the only handicap, let's say, of using the computer node.
But the node sees our home directly real time. Right?
You see your home folder, you see your files. That's the nice thing.
But I see real time. So if I open a new terminal, start changing
yes,
my
yeah, exactly. That is just making a binding in your home folder. Is one of the few pieces of file system from the host that are visible on the image.
Make sure you're up front of questions.
Oh yeah, I will help.
You might keep them here. That's
Yeah.
your question.
Okay. You are in, right? And you work on the problem.
Yes.
With the display. Do you have export?
Yeah, I'm an expert.
That's right.
Yeah.
Yes,
Yeah.
that's why.
Oh, dash X.
Yes, it was something. Oh no, yeah. Wait. You are from the very beginning.
Yeah.
Here, you need the one. So now enter password.
Gotcha.
Are you in? That's okay. You are inside the computer. So I will wait a little bit until he reaches the same level as you, and then give me some. So I will take the opportunity to try to redo a little bit what I did, the whole thing, so you can. Instead of advancing more, I prefer you to reach this point. This is something that for a lot of you probably is what you really like, to have a machine where you work and you don't want to worry about submitting jobs and all this stuff or programming on fancy stuff. So this is what I will do. Let me see. Okay. So I am starting from the very beginning. I will do it comment after comment, but I will show you the whole procedure so you capture the idea. So first is logging. So first thing, I'm on my computer. I jump into Express. That's into the cluster. So first thing, I would like to check if I did it right. You can test with a clock, and you should get a clock here, a window from a window here that pops on your desktop machine. So this window is generated from the server. So you got Windows. Check. Next thing, my interactive session. This line. So let me go to the very top. This line. With this line, from Spruce, I jump into a compute node that has been dedicated for me. So I'm not competing with anyone else. So I got a few cores to work entirely for me. So I execute this. Typically, I wait 2 to 5 minutes maximum, except for some queues. So when they are too busy. But and this is, I would like to be sure that you two are on that place. Are you there? Where you? No, you don't have to exit because you are ready. You are fine. You are fine. You don't need to exit. You are ready also. Okay. So somebody else is. You. First. Good. Go to the terminal and keep what else. Somebody else? You are inside the container for our studio, but you are not executing our studio. So you are in, right? You are in. Now next thing is right here. So we are in the compute node. You know that, we know that because the name of the machine is different. Is this one or something like that, but it's not the head node. Next command is module load singularity. That one. That command gives me access to singularity. All right. I execute that command, and the command singularity just that. So I can load any of the images that I have or to cluster. To see the images, you want to see them. So for containers are just there, right? And let me show you again. Let's say just use this one again to show you what I have. So singularity, shell, shared software, containers, Jupyter, same is IP. What I did mean for someone for hearing is to avoid this issue for people who it's getting the lines not sent to a new line. I did a trick. I did this shared software containers Jupyter Xenial.smg. So allow me to just get exactly that associated to a variable. So I create a variable for that. And singularity shell ing. So that way I compact a little bit the extremely long line. So let's see if I can. This line. So I create a variable just to shorten the command line, and I got into the image, right? So I would like you to be here. And are you there? Okay. that's okay. One slash. That's not. So singularity here. Okay. Now you are fine. You. No. You're fine.
Okay.
You're fine. So singularity.
So, but like,
Shell,
Yes.
color, right. Just you are in.
Right.
Okay. Are you in? Are you in? On the okay, you're fine. You. Okay. Okay. So I will show you again the console, just for you to see. IPython. IPython 3 Qt console. This is the Qt console, by the way, if you don't execute this way. So IPython offers you 3 ways of working for those who are familiar with Python. The IPython normal console, where you can still do this, and it's slightly different. Matplotlib Qt TK, and already have my commands here. Okay, and import blah blah blah. And this, the only difference is that it pops up a window with my plot separately. This is one way. This is actually how I work most of the time. Popping windows instead of using the Qt console or the Jupyter that are heavier. So this is it's a very light way. So for getting images, see if everything looks fine and move on. This is one way. This is just the interactive terminal for IPython, the original IPython environment. Another way is Qt console, IPython Qt console, pop us an entirely different window where I can execute, let me see. In this case, I would like to have inline. So I would like to see the images with my execution. And I see the image inside my terminal. So it's a terminal with a graphic user with a plotting capability attached to it. Second way. So and third way is the notebook. Well, I have here on that already, where you create this, and you can save your notebook. You can create, insert, cell above. I can put the title here. This can work like a real notebook. Title of my test, and I can select this cell, and this cell become heading. And I can have chapter, sections, subsections, and showing, okay, I am doing this, I'm cleaning my data here, I'm making some plots here, I am reducing this, I am integrating here, I am compacting here, I am doing this step by step. And you can show, if you're a student, you can show to your advisor, okay, I did this, I did this, I did this, this is what it's done, this is where I have issues, so someone else can help you without having to suffer the pain of understanding your code. And you can save this, you can transfer it to somebody else, and they can reproduce your execution and see if everything looks correct. And again, there are places I can show you. Well, don't have internet here, but here I have. If you are curious about IPython notebooks, this is something that I will comment more on next time. But, there is a collection of Jupyter notebooks. Maybe they have it here. Yes, the Jupyter Hub. Oh, no, not this one. This. So if you are curious about this place can host notebooks, and also you can indicate this that you have notebooks that you have created for some other people. I have some of my own that I did a few years ago on my area, whatever. And so people can follow the instructions and reproduce like a tutorial. And they have a tutorial for a variety of topics and things like that. So let's go back. So let me explain you a little bit. Okay, the exercise we basically did it with this RStudio to get that image for you. There is another exercise. Probably we don't have too much time. I was not expecting to take so much from it, where I am taking some data from the census here, and I am using that also. I downloaded, so you have it on this, and the idea is to execute a script on that. The script is basically, if you see the script, first right here. Let me see if I can show it really quick. I will leave here. This is what I would like you to see. I didn't for the simplicity. So what I did here is this file from the census with the population, and I have a small R script. This is for the non-interactive, to create a submission script where you would like to process a little bit those tables. So basically, I'm getting what is the most populated state, the lowest, the average population of states, things like that. Some data from the latest census, probably. What else? I don't know. Probably we don't have time for this, so I will screw your lunch. Showing you how you can enter on a machine. I was preparing this, but probably will skip it. How you can create with very minimal recipe a script. With that, create an image, and with that image, start tweaking elements until you get a good image for you for the kind of things that you would like to do. And at the very end, you got an image and you see the result. I probably don't have time for actually demoing you the whole procedure, but I have the image right here. So let me see if I can get to that.
What's CentOS?
What?
CentOS.
CentOS is a distribution of Linux based on Red Hat. So they took the sources from Red Hat and they create their own. It's a free version of Red Hat Enterprise Linux. Well, let's do something. I will advance with this, and later, if we have time, and if you're interested, I will show you that. Anyway, let's describe it here. How you create an image for a package that uses some libraries, some graphic user interface library, all libraries from the old times. Let's say from the times of Turbo Pascal. Some of you are old enough to know what Turbo Pascal is from that time. So basically, I'm taking that library and compiling that library, and I'm creating installing a software that uses the graphics.h from the old time. And here is the step-by-step procedure, but I'm way off my time on this.
So on the server, right?
So what I did was, the idea was to show this on a virtual machine where I got root capabilities. So I was planning to show you how to create images from scratch for your purpose. And my excuse for that was using this library, this old library, the Leap graphics, for getting that and creating some fractals and some nice images on that using that library. But no, the time is, there are more important things to show on this. So let's move to Conda. I'm way off my time. Let's see.
We do a 5-minute break.
Oh yeah, 1 5-minute break. That's more than fair. So yeah, we will return. Let's say we return 5 minutes. I will take 1. Okay, and a few minutes for you up until we start with the real thing. Let me show you this. here is one challenge exercise where I am showing you how to create step by step an image. Supposed to be doing it on your computer, where you have root access. So you basically learn by mistakes. So you need a Linux computer where you have root access. And we need root access to create images. And you install Singularity there. And with that, you can start by learning from your mistakes somehow. That is what you actually do it. You start with something small, and you learn which are the packages that you need in order to compile step by step until you get something that is good. And you reach that point, you create a final image that we will show you right now. So here is the procedure if you just want to follow it. So we start with a very minimal recipe that is this. Forget about this. So those lines is basically 20 lines here. That comes from Docker. So Docker reconverted into a Singularity image with CentOS. And I'm learning what I need to install, which packages I need to install. So I realized that I need to install these packages in order to compile this software that comes from Turbo Pascal that I told you. And what is the library that I need. So how I configure, make install that library. So I build that and I create my image until I got something good. And this is the final recipe for that, where I'm downloading what I need, all this stuff, all this. So what I will show you is the result of the Singularity shell software containers. CentOS final. Right. This is a very simple images. It just has some here in that.
In our case, this will be on our home directory.
Now, let's say after you create your image, you move it to a Spruce, you move it to any cluster that offers Singularity, and you're running. You run your software.
I need to keep it in my
you need to create it on your computer.
I know, I need to keep it in my folder.
And you keep it in your folder. You keep it in your folder. That doesn't, so I put it here so you can, if you want to use it, but yeah, you can keep it in your folder. Some images could be 1 GB, 2 GB. So your 10 GB is kind of small for that for that purpose. But if you have a real account, you have a Scratch folder. And the Scratch folder, you can store terabytes of data and nobody cares. So that's why eventually you want to move that to the Scratch.
Oh, Scratch is...
Scratch is... Huh?
Anybody can see.
No, not everybody can see. It's in a space. The difference, okay, we have your home accounts. You receive, when you ask for an account, you receive 10 GB home folder. That home folder receives backups, it has some extra protections, it has some extra qualities. The Scratch is a land that is protected for you, so only you can see, if you want, your data, so nobody can actually step on you. But there is no limits on quota. We have like 400 or 500 terabytes of data available for storage. So, but there are no backups of that. It's too high. It's too big for doing backups of, half petabyte of data. It's not feasible. So it's considered you have the playground. You have your data there, your files, big files.
And keep it in another place because they're not backup.
There are no backups for that. So it's a place where you interact with your data. And at some point, it becomes full. We send a message to our users, okay, we need to clean this. And we give them some time, for them to clean. Some people just don't listen to us. At some point, we have to actually delete the data. But we try to be kind and say we will not doing that without telling. So what I did for showing the exercise to you is a couple of, I wrote and modified this. This is a small code in C that uses this graphics.h. This is what I call it, this Turbo Pascal, the old Turbo Pascal, or Turbo C, or I think it's the Portland, all things. So, and I use a library that allow me to use that. So I got a command that is called circles, and it will create a simple, nice figure, plotting from the old times. This one. So this is one. And another one that I create with the same code is C, is this one, Julia. It's small, well, not so small, but relatively simple C code. So I create the image with that code inside and compile it, and it produces this. Let's see. Oh, yeah. Julia, let me see this one. It's really slow because it's using a lot library that's works not very well. The code is a pain and it's very inefficient, but you will see the result. So I give you a couple of minutes before we start. So this is how people used to program like 20 years ago. And now we will be closing the singularity containers, and we will talk about something completely different. It's Conda. You are free to install your own software on the cluster. And you can, and I do, without any special privilege, compile your own codes. You are willing to do that. Compiling code could be hard. Compiling efficiently or optimized for specific architectures and it's tricky or requires some knowledge, and that's what university hired me to do. But there is an alternative to that. There is a project called Conda, where you can have your own environment, very similar to the Python environments, very virtual environments in Python, but it's far more general than that. It allows you to install packages directly from internet and having your environment isolated with your own software and with the versions that you want, and create those environments and create several of them and manage them, so you can move your research without having to ask me or ask us to install some software for you. So that gives you freedom, and with that freedom, the responsibility of managing your own software. There are basically two versions of Conda. One is Anaconda, another is Mini Conda. I suggest, if you are working on research with this, to have Anaconda, for example, on your computers. It's a nice distribution. It's, when you install it, it's quite big. The download is like 700 megabytes, and you install from the very beginning. You install like 100 or something packages right away. So you get a very decent collection of software, Python software, and from there you can start installing your own packages. And you can install packages from the original repositories, but there are also alternative repositories. There are two that are well known for me, at least. One is called BioConda, that specializes in software for bioinformatics. Another one is the Intel repository, where the people from Intel provide packages optimized especially by them for Intel architectures. So that's another alternative. Those are called channels. So we will talk about that in a minute, the details of all that. So what we have on the cluster is something else. It's called mini conda. A mini conda is exactly the same thing. There is nothing, don't understand any handicap on the word mini conda versus anaconda or something. It's just that when you install mini conda, it just installs like a minimal set of 15, 20 packages and give you there, put you there, and you install whatever is left by hand. So that's what we have on Spruce, on Thorny Blood. Anyway, so let's move out of this. One question: we will be using Quarks for the rest of today's session, or? I don't think so. I don't think that we will be using the Windows, popping Windows during the rest of the day, I think. At least I don't think that you actually need it. Yeah, I don't think so. I think that if you are having issues with that, it's okay. I don't think you need. So I'm still using this session. This session is there for a week because I never specify any limit. So I still on. If you'd like, you can. If you're still log into your session, it's okay. To the compute node. Otherwise, if you want to do it from the head node, it's okay. But for the purpose of this lesson, it's okay to do it in a compute node or the head node. So Conda. So all that you have to do is to see the trick. Is this. This is kind of a fake module. Conda is a little bit special. So what I will do when I execute this module load Conda is just giving you the line that you actually need to execute for getting the environment for it. So this is what you want to do. Conda. Okay. There are basically two commands that you want to use. Looks like one command. There are actually two. And everything is to manage this. The software is everything with Conda something to get the list. Let me see how I wrote this. Okay. So I show you here how to activate the source. So if you want, for example, to do it all the time, you can execute this line or add this line to your .bashrc. So there's a file here. This file, .bashrc, you can add this line and you get Conda every single time that you log into the cluster. So you don't have to do it. You get Conda because you work with Conda all the time. So it's up to you to do that. What else? Okay. There are basically three concepts that we need to understand very clearly when using Conda. One is the idea of environments. the idea of channels and the idea of packages. Environments is actually a folder in some location where when you install packages, all those packages end up there, being installed there. And all those packages supposed to work together nicely. So the dependencies between them are adjusted by Conda. So that's the role of Conda basically as a package manager. So the first thing that you would like to do is to create an environment. So you execute the Conda, create, name, and the name is up to you. This is how I prefer to create it. What I mean by that is that you can create directly an environment with certain list of packages directly. I prefer to do something else, is create an empty environment and slowly start to fill in with the packages that I would like to have. For example, someone asked me for packages in bioinformatics because he wants to teach a class on bioinformatics and he wants to use a collection of 20 packages, different assemblers, aligners, a bunch of stuff. So I prepare an environment with that collection of packages, nicely collected and on a single environment for that professor and his students. So doing this, I'm creating an environment for me, just for me. Wait. Oh, yeah, I forgot about this. Yeah. For at least for the create, this is not a mistake. You don't want to create environments on, you can use them, but you cannot create them on a compute node. So, mod load conda and execute the trick. Okay. It will tell you that it will create an environment on your home folder under .conda, the hidden folder, the environment my. And you can create several, no problem with that. You can create a collection of different environments with different versions, which is very useful for developers because you want an environment with Python 2 point something, 3 something, 3 blah, 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 with different packages, different versions, and you want to test the software in those. And so you can switch into any single environment and test your code that everything is fine and it's okay. So it creates the environment for you. Now, next thing is to enter into that environment. And they give you here the trick is to execute this on the activate IM. These specific instructions have changed on the latest versions or the last version of this. This is how it's done. But if you see on the document on internet, probably people mention the old versions where you have to actually source on the script or activate the script or things like that. This is the old version. This is this is the new one, and probably this is what we're moving towards. That everything is conda something, and the comments are now better organized. They are being polishing the whole structure. There is still some difference between this conda something, conda create, and conda env environment, env create. Or there are discrepancies still. They are converging into a better development of that, but they're still on the way. So I activate an environment with this. Conda activate my environment. And I can execute Conda list and see that effectively I have no package installed on that environment. Right? Let me see what I measure here. Okay. Before I'm installing package on that environment, let me show you a little bit. Let's see. We have a few environments on central install. Most of our users for Conda, they don't really rely on us for installing environments for them, except, for example, professor who wants to teach this for their students. So we need to centrally create the environment and put it in a location where several people can access. But typically, the researchers who use Conda, they create their own environments. They have their own collection of environments, 10, 20, I don't care. And here is this. This, you see, lives in a very different location compared to the others. Because this is an environment that I create as training 001. And only me can access to it. So, let me see. Notice that every single time that you activate the environment, you see a change on the prompt. That change helps you to realize that when you execute commands, it will try to see for the comments on that environment. So if we install Python, and we probably will do in a minute, it will be the Python that you install for that environment. It will not the central install or any other. It will be that one. That one takes preference over everything else. Okay. Imagine that we want to install a package for that environment.
Packages are, this case
could be libraries, could be actual executable programs that do some purpose. Let me show you something. For example, the collection of packages here in BioConda. And that gives me opportunity to show you the difference between Conda and the different channels. BioConda is a channel for Conda packages specialized in bioinformatics. And they have a list. We'll try to impress it here. So they have a list. I don't know. It was several thousands of packages, which is very typical in bioscience to have thousands of packages. And with different degrees of reliability. Let me see if we can search for something. Let's see. Something. Okay, maybe this one. Band tools, for example, band tools. And they will give you that package. If someone needs to use that package, they can install it from the BioConda channel. get that package. In particular, for people who use Python a lot, the Intel channel offers a variety of packages optimized by them, by Intel. And they include some packages in machine learning, scikit-learn, TensorFlow, similar. So I asked the system, okay, I need this package. HDF5 is a library, actually. And Conda basically search a suitable solution of dependencies, versions, trying to get the latest version and the compatible dependencies around that. So I will say, yes, I would like to have that software. And it just installing for you. Again, you need to be in the head node, and this is how you prepare your own environment with your own software. Conda list, and you see now that we have populated that.
How is it the package we have?
What?
I can have a list of the packages I can install. Or search in a list.
You can search. Let's say search. Search. Let's say Python. But there are too many probably. This is probably not good. Yeah. There are a number of them for different versions and different builds of that.
How do I select the one I want?
And then they have different versions here. So let me see if and you can do something like this. I would like to install the version of Python 3.7.2. So you can declare very specifically which version. And you can be very picky up to the level of the build. So you can also say, okay, I would like this one. Okay, this one is the same thing, but I would like to have Python with this version build this with this name. And we'll try to see how that solves the environment, which are the dependencies that it would bring into the collection. And it will start downloading those packages and getting the environment for you. So Conda just give you a white canvas where you can start building your environments. And the idea usually is that you create your environments for different tasks or different purposes. For example, you want to work on a project and the people who develop that knows that works with this version, this version, or this version, or this version. But also you are working on a different paper with somebody else who use this in different versions. You will get in conflicts. So it's better to keep those things separately. And you know that if I am working on this paper, I will be using this environment. But now I'm working on a different paper from some other collaborator, and I'm working on that. Or also, you agree with your collaborator that we will be working on the same set of environment. So, and you can send a recipe for the environment to your collaborators, so all of them are on the same page. Otherwise, you start getting mails, okay, this is not working, but what version are you using? They're using this, but it's not working because I'm using this, and you will waste a lot of time just trying to figure out which is the right version for the right thing. So this is good. That's it. In the meantime. So what I did here was installing a package, and it will download the package and get it done. As I told you, you can be very, very specific on which software you want to install and from where. So at this moment, I am specifying that I would like to install a package from this channel, specifically from this channel. This package with this version and with this build. it will be up to Conda to figure it out what kind of compromise you have to be made in order to get that package. By that I mean that sometimes you have to downgrade some packages, otherwise you have to upgrade some other packages. Some packages need to be deleted. So it will show you the best solution to get that package for you. If the compromise is not acceptable for you, the best that you can do is create an entire different environment with that in order to avoid collisions or downgrading code that you don't want to downgrade. So this is what happens. You get a plan. You get a plan. Which packages will be installed? Probably can do this. We'll see what happens if I do it here. I don't know if I get into troubles here with this. Because I installed Python and I installed the other one. It's not clear, but it will be, yeah, it will be updating some packages, and some other packages will be change the version because they have to make compromises with that. Do you agree with that? Okay. This is what a package management does. And let's say Conda list, and it will show you that now we have a different set of packages. So I have now MPI with a specific version. And now you can do something like this. Let's say that you want to update one package. You Conda update. Let's say what? MPI. Let's see. And it will try to offer you which is the solution for updating one specific package. So if you want to update this package, we will have to change the OpenSSL, the certificates. Do you want to agree with that? Okay. So really neat. They're really useful for actually research.
But you cannot share your environment.
You can share the recipe, and you can share the environment. If you have, for example, some researchers ask for having a folder where they can share with his or her students. So that's a solution that can be arranged to have that kind of thing. But typically, instead of that, I create the environment and put it in a central location, and everyone can use it, and it's okay. What else? What else? Okay. So again, I show you Conda list. You can add channels. Again, this is one BioConda. This is what I show you here. This is a channel with thousands. I think more than 8,000 packages in this collection. Another one is the Intel. You see, the Intel Conda channel. See, yeah, this one. This one is something that I use. Sometimes I just prefer to compile it myself, but they have a nice collection of packages provided by Intel. So of course they are using the MKL, their own software.
Those are compiled files.
Those are compiled. Those are packages.
So Conda knows the architecture of your.
No, that's the point. That's exactly what I do with myself. Sometimes for the Conda. No, the packages need to be generic. So they need to be for a generic 64 machine. So they cannot take advantage of a Skylake. They cannot use the extensions. Or the best they can do is with something called automatic dispatch. So they can decide, okay, create a binary, okay, compile this, targeting a normal, basic 64 machine, let's say, eventually not too old, but baseline, a machine with AVX, and eventually a machine with AVX2. And that code will try to figure it out when during runtime, which line, which execution will follow, depending on what it can take advantage of. But when I compile that, I can tune it specifically and only for the Skylake AVX512, and I get the best performance of it. So that's because I took the responsibility on getting the best performance for that.
You can create your package.
You can create your own packages, yes. You can create your own channels even, but again, it's like everything, let's say. At the end is who you trust. I probably trust Intel and probably trust the people in Bioconda, but other people, I don't know. Okay, so you can see the different packages here and how you can edit in one file. You can have your own list of channels. So you can have Bioconda, you can add here the Intel channel and install the package. That's actually the exercise. How you remove packages. This is the command for removing one package from your environment. Or if you are in the environment, you can just simply remove that package. You can delete the entire environment with this. It's okay. Or using the conda-env list of commands, you can do it. So, and this is what is interesting. At least if you are collaborating with somebody else and probably in a different university, different place in the world, and you want all of them to be on the same page. So you agree with them that, okay, we will work on Conda. So we'll have the same packages and same versions of packages, and everything will be same on your side, on my side. So you can create the environment and you can export the recipe. Okay. So let me see what is the effect of that. It will create a file in a language, in the market language is called YAML. And it looks like this. This is what you share with the people. It's very, very strict in the sense that they declares, okay, which channels will be enabled, which files, which packages need to be installed, and for which version, and eventually for which build. And the only thing that you can play with, if you like, is to install in a different place. So you can play with this final line, and you share that. You send that by email. Okay, this is the YAML, this is the environment YAML file, and all of us, we will be working on this. You create your environment, I have my environment. Everything should be able to see exactly the same thing. That's a good thing. And eventually, if you like to relax that, this specification, all that you have to do is edit this. For example, I don't need to be a strict on the builds, so you can remove this, and you will start having a more flexible environment. So it's up to you to flexibilize that for you. So otherwise, you can create something like this, your own environment by hand, and use it. Let me see if I can do this quickly.
How I use the YML5 if I have one?
Like this.
Ah, okay.
This is the the line to create one. So you can create by hand. Let's see, conda deactivate, being new and let's do it with time, let's say. So this is the YAML file. I'm copy and pasting that. So this is the file to create environment. Yes. And here, yes, -7. Contact create and no, it's conda m. Probably wrote it wrong. Yes, I have a bug in my, I have a mistake in my. Oh no, it was me. It's like this. It's correct. It was me who wrote it wrong on the command line. Conda m create and it will create that environment with the latest versions of those packages. Yes.
So the difference between Anaconda and Miniconda is that Miniconda downloads.
The difference is when you install Anaconda, after you install it, you already got like 200, but you can still do this. You can create your own environments. That it's just that from the very beginning you get a bulky installation.
To avoid installing all the time. Avoid downloading.
No. They will still download those packages. So it's just the Anaconda is for people who probably they're not interested in creating their own environment, and they have just a standard installation where everything works and they don't need anything special. So you just need something, and they don't care the space is their own computer. So they install that and they play with that, and they eventually just install new packages on the root environment, the initial environment. That's it. That's.
So if I don't call any environment,
you have, if you can call an environment, you are already on the environment. What is called the base environment or the root environment. It depends. I think I'm call it root environment. But you have an environment always, and you can install packages on that environment from the very beginning, especially in Anaconda. And so in the Miniconda, you work differently. You have a minimal set in order to create your own and start playing with them. So that's what I actually prefer in a cluster like this. And I create this environment based on that recipe. And you can see that this environment has these packages. So it has the packages that I ask and the dependencies of those packages, Conda, NumPy. So this is, let's say, I have a minimal environment for data analysis. Let me see what else. Oh, this is when you start doing this for real, seriously. Is that you have 10 gigabytes of quota, and this folder .conda gets filled pretty quickly because it downloads all those packages and they are stored in a cache place. And after the environments are also installed there, so the .conda grows and grows and grows and grows, and you hit your quota, and you cannot write any file after that. So what I mentioned here with this note is that if you are really serious into this, the best that you can do is to move the entire .conda into a Scratch. You have your real account into a Scratch and create a symbolic link. So this basically is the trick. You move the conda into a Scratch and you create a symbolic link from that .conda into the is like a shortcut, the equivalent shortcut in Windows, where the system still thinks that there is a .conda, but that .conda is in a different place, and you can grow and grow and grow. Otherwise, another thing that you can do is just delete the packages, because if you need them, you can download them again, so it's not a big deal. But and those take a space, so this is something that. So the exercise, I will give you a few minutes so you get some experience on this, is create a couple of environments. You put the name that you want, and you create an environment with Python 2.7, another one with Python 3.6. And on each of them, so the idea of what it said, I create a couple is because I expect you to activate one, activate the other, install NumPy, SciPy, and IPython on each of them. Network and Pandas, so a few packages in Python for scientific computing. And now try to install, to add the channel for, this one is, let's say, the bonus point. To add a new channel for Intel and install TensorFlow as scikit-learn, a couple of packages for artificial intelligence, for machine learning. On.
Is there any way you could walk us through these steps?
What?
And like we could do that together, that you do it and we do it with you.
You can do this, yeah. You can just do this. This is the first part of the exercise. You start playing with the conda commands. You see in the web page all the things that you can do. So you can go back, scroll, and see what you have to do in order to get those two environments. You set up the name that you want for those two environments, and now check back what are the commands for activating for activating and installing packages. And I will give you a few minutes, let's say 10, 15 minutes. And I will be around here helping you if you got stuck. So at least you put your hands a little bit. This is, I hope, basically a hands-on to you. I want you to actually do this and hit the wall.
So let me ask one question.
Yeah.
Suppose you have a software that's not on Conda. I have one for robotics that's not on Conda.
Okay.
Can I create this is my machine, not on the cluster, maybe.
Uh-huh.
I create an environment and install package inside this environment. Can I still use this program that's outside the environment? So the
Yeah. Let's say what I imagine is you have your program, robotics, really to say, robot. So, but that program has dependencies.
Right.
Uses some other things, right? It's
Right.
written in any language, but it uses some other things. So what you can do is to create your environment and install some of those other things, and after use those to have your own robotics code working on your machine. So there is not isolation at that level. So this is different from the containers. In the containers, you have to put the software inside. Well, you don't need even to do that. You can put it outside. You can play. It's a different thing, but
the environment only add packages.
Add packages. No, but it can hide packages, because if you are installing, for example, Python 3.6 and you are not loading any module, that is taking precedence on the Python installation that we have on the Red Hat machine. So it's putting a layer on top of that, and that's what you see first. So, and that's what probably you want to do. You have your code, and your code needs something. So needs some libraries. So you install those libraries, and after you can run your code, because the first thing that we'll see are those libraries. When you are out of that environment, it will have broken dependencies everywhere. So that's exactly what you want to do. Okay. So tell me if you got stuck in any of those 3 lines of the exercise, as far as I know, people who uses most of the time this is people in genomics, because the bioconda is really important for them. Some people in astronomy or astrophysics, because they have collection of packages in that area in Conda. And Python is basically the language that you want to learn. If you only have time for one language in your life, Python is the language. Later you can use something else. You can learn R if you like to. You can learn C, Fortran. But nowadays, Python is the dominant language. Let's say the first language. Yeah.
I got an error.
Good.
So I was trying to create the environment like
right now it's because here, so so you create first environment. Let's say let's call it 5. Makes sense. 27, right? So this is an empty environment. This is the first. They will ask, do you agree with this? Say yes. And you have your first environment. It's empty. The name doesn't mean anything right now. Let's create a second one. Let's create 1, 4, 3, 6. Yes. So now execute conda list. No, conda and list. Conda. To see the conda is the environment. No, that's fine. Okay. So apart from those that are centrally installed, you have 2 environments right now. Those are empty. 27, 36. So now let's enter into the 27. Conda activate space activate space 527. Okay. You are in 527. That's your indication that you are inside that part. Now you execute conda install space, those commands here, install, and you start conda install space, and you start adding the packages here. They're up and down. Which are the packages that I asked you to install? Python is 1. So okay, Python. So you want install Python equal 2.7. That's cool. Python. I think this lowercase. The bottom is lower. This low.
I can start using it, or
you can mix those things. You can install Git and use Pip to install. You can make those things. Be careful.
some packages are not on Honda but are on Pip.
Exactly. So you need to be careful on how you mix those things, mix and match.
That's cool.
So actually you can do the whole thing. You can create a singularity environment, a singularity image, with conda inside. This is the very good place for it. So the instruction, all the instructions. where you have that image with Conda, and from there you can start installing packages, your own environments, and you basically get an image that is like one canvas for installing things in places where people do not offer content quite well. So content we don't say that's perfect. If you want to do it that way, you can just keep entering, you install the first code. As you said, that solution yes. Ready. And we'll start downloading those packages one by one.
Is their own part of the pipeline.
Yes, this is the solution. This is the proposal. It will search for Python and what it needs, and you declare that you want Python 7 here, 2716 here, and so it will try to follow your wish. Okay, 2.7, and what it needs to install as dependencies to complete that.
So I don't use that 7.
No, you don't need anything special. We try to find the first 2.7 that is good enough. If you want, you can, for example, buy Conda search Python and get the entire list, and okay, decide very specifically I want this version and this and this. But if you just want something generic, and I ask you for something generic, 2.7, you will search for the best 2.7 that you can find.
So like there was a version out there that's
Yeah. No. It's not related to the content that I offer. This is coming from the internet. This is searching for all the packages on internet for those channels for the latest version of them. So it's in real time. You are searching for what is available. It's not attached to the version. What I do from time to time is updating the conda on the basic layer on the cluster. So to install the basic package, updating the basic package.
but once
If you are in a compute node, you cannot download. That's why you have to do everything like this. You have to do it in the node first machine. So probably it's I don't know why it's maybe too many people is doing exactly the same right now. So yeah, we got some crazy people. That's fine. And the thing is, those packages are stored in the .conda and package, something like that. So if you want to create a new environment with pretty much the same packages, it will just use those that are already downloaded. So the next time you do it, so not for this exercise because I asked you the 3.6 and the 2.7. So those are different packages with different dependencies eventually. So you will have to download those separately. So that's why I ask you for creating those because now you will have to deactivate one and the other.
how do I know it's
It will show you this is still okay, around here is working for you, you're going to start working for you. And leave this place because you are a computer node, you don't have internet system. So you are fine. And do you have contact with the internet? No, you have to execute the game on the no, before this into this.
Oh, so okay, that's the problem too.
Yeah. So are you also out of the
I'm out. Yeah,
you are out. Yeah, yes. So, yeah, so now you solve that file. probably can tap, hit tap all the time. So now we start executing that. So now, right, if you have conda list, execute conda list. Yeah, you have conda. Okay, this is from the basic part. So this is the mini conda. This is what is the conda. So this is what I use. And so now you start creating your own environment. So search, check your documentation of creating an environment. And I just use two environments, one for Python 4.7 and another from 3.6. So you set the name that you want. The name doesn't matter. The name is for you to know what it is. Is because it's not. Let's check. Let me check the network. Too many of you executing conda. Nothing. Let me see.
Networks are not on.
It's not working? We got stuck. He was trying to download it, never.
Networks is not on conda, so I installed.
What network? Oh.
Networks.
Network is not in conda? I actually never checked. Let me see. Conda search networks. Network. Probably it was my mistake. That's my fault. That's my fault. I apologize for that. It's with X at the end. That's my fault. It's a library for graphs, for playing with graphs in the mathematical sense. Networks actually. So yeah, it's with X. So sorry. And you see when I execute the search, and you see that there are several versions for different Python. So there is one. This is what you will get from the main packages, the 3.6, and this one probably that's what you will get from the 2.7. Correspond to different versions of networks. So, yeah. All that I see is that many of you people online is executing exactly the same thing. It's all of you are downloading the packages, and those packages are independently downloaded. So there is no mistake.
If I don't have a conda RC file, I need to create one.
Yes. If you want, there are several ways. One is that you can let me see. Yeah, one is that you can create your own, Another one is that you can create an environment specifying that you want to install from a specific channel. I think the best is if you are working with something, it is better to have your own Conda channel. And so I'm not into bioinformatics, for example. So I don't put this one. Instead of this one, I run my file here and replace it by Intel. So I have my Intel channel activated. So when I need something, I would search for that. This is good also. The order matters. Here. When you search for a package, it depends. You should also have this one default, so at the very bottom, because the packages specialized channels should take preference over the non-specialized ones. So eventually, when you add the Intel channel and you try to create an environment, and you install those packages, it will try to get those directly from the Intel channel instead of the Forge, the Conda Forge or something else. So pay attention to that.
Sorry, where was the default?
The default is the set of packages maintained by the people who create Conda. So, but the BioConda is created by a conglomerate of people interested in bioinformatics that have created the repository for them. So they are not managed by the entity, the institution behind Conda. So it's a different, they have some partnership, they collaborate, they are considered very stable, but that's not the same thing. And the Intel is probably the guys in Russia who manage the Intel section for software. So who have that, the Intel channel.
Get out of the, so now that I installed it into the folder,
So,
now I would like to,
okay.
I would like to do the same thing.
Okay, so Conda deactivate.
And so I'm not going to click this.
Yes, Conda deactivate.
Now back to,
Yeah, Conda activate the next one. I think it's 3.6. So you can go here and replace it. Execute the same commands.
This phone does something new.
Well, I don't think so. It's been around for, it's 5 years.
Here, no, there's a question in chat.
Yeah, okay. But is it? Oh yeah, the file doesn't exist, but the Conda RC file doesn't exist. There is, so let's see. You can create one. Or there is another way, but I have to search for it. The documentation. But this is okay. You can see the Conda. How you create. There is one command that creates one for you from a template. I can find it. Here.
Add channels.
Yeah, this is one. So yeah, if you execute this, is another way. If you execute this, it will create a Conda RC for you. That's not how you used to do it, but probably this is a new thing. But Conda, yeah, Conda's been around for a while. I don't know how old it is. I'm actually curious. Yeah, it was okay. It was created originally from Anaconda, so 2012. So it's, yeah, 6 years ago, more or less. It's not super new, but yeah, it's been a while. So again, notice that the set of commands. There is something else. Okay, now you need help with this, or you don't know. I would, for example, conda execute this. Conda create minus help, and you get the help for the command, for the subcommands and the different things. And just notice that conda create is different from conda m whatever. So this is one of the things that had not been merged into the whole process. So the set of commands associated to conda env work differently, and they expect different things from the commands conda something. So at some point, I imagine that it would merge those. Yeah.
Is that like
No, it's because conda is not Python equal to 8.6. Is the declared version. It is okay. It's okay. You don't do it. Okay, so and actually, for getting this from the recipe, you have to use this actually this one, conda m export to create the YAML file, and conda create -f and the YAML file to create environments from the conda. This is where it becomes a little bit confusing. It's different from this one. Conda create. This will not work with this YAML file. Just for you to see, let me see. Okay. Yeah. This is the location for the environments. Okay. I will move now to last thing, otherwise we'll not get lunch. I will try to compress a little bit this, so it can offer you some. Yeah. And we will talk about the version control here. Okay. Imagine this situation. One is you are a software developer, you are developing some code for your research, and you are collaborating, or you are trying to keep your students collaborating into that, or writing or testing or doing something with the code. So you are into a collaborative effort in this. And you want to keep some history of the changes. if someone introduce a bug on the code, on the script, whatever. Version control is a solution for that. Another one is if you are writing your thesis or you are writing a paper, and again, you are collaborating with some other people, one way of keeping all the people on the same page with something like this. There are elaborated versions of this where you can write papers collaboratively and using web interface. I remember something called Autoria. This is the one that came to my mind where people can write the paper. Several people can write the paper together. It's called Autoria. There are some others, but is this? But the simplest way is something like this. Again, if you are writing your thesis, this is really good. To keep a history on the changes that you introduced, the plots, or things like that. So what it does is basically keep you a record of the changes that have been happening on files, especially on text files. So it depends on the area, but at least in basic science, in particularly in physics, chemistry to some degree, and mathematics for sure, LaTeX is the best and probably the only way where you can write papers. But yeah, there are some journals that accept doc files, but it depends. It depends on the area. How hardcore are you in science? So those are basically text files. So this is perfect for that. What I will do is to show you a little bit, step by step, the kind of things that you can do to create your own repository and keeping them management. What we will do is purely on one single directory. I will be committing, I will be doing locally. But again, the university has some agreement with GitHub, so we can offer through us, through research computing, private repositories for you. So you can request a private repository, you can create. You can also create you can also request us a public repository, but you can get those for free. It's not a big issue. But private repositories are for a price, but we can offer them for you if you would like to have some privacy, some for writing papers or something, and you can decide your collaborators who can have access to see, change, do things on those repositories on GitHub. So basically it works like this. So this account is brand new, so let's see, yeah. Again, so this one is the first thing. You need to do this just once. To declare who you are. Okay, doesn't matter. You don't have to tell the truth anyway, but it's also good to have some to record. So how this works? Now let me see if I can go to this. I will do it directly here. So for my exercise, I will pretend that I'm writing a paper. So I have some data, some small data. So if you are really working with big data, terabytes, of course you want to do this. But what you can do is to have just the tables that you need for plotting, the final tables that you need for plotting some very selective sets of data. You have the paper, location for the paper, a location for the plots, and some location for the scripts. Eventually, the scripts will take data from the data folder and make some plots in PDFs and put it down, and that's what we do. So the first command is git init. And it will create a hidden folder that you're not supposed to see or to touch, but will convert this into a Git repository where you can start version control any change that you start doing on the files after you insert them into the system. So this is the first thing. Git init, it will create this. So if you have the opportunity, I'm doing this right here. Right? But you can create explore this on an independent folder. I'm right here. And I initialize my folder to be a Git folder. So version control that. So let me see what else. Okay, in this case, I show this out of this, but this is the command that you execute the most. Is git status. It will basically tell you which files have been inserted in the version control and needs to be acknowledged the changes. That means that's called stack those files, or insert them into the system. So right now, I will tell me that this tells that I have it detects some folders that are not under version control right now. So those are brand new, and they don't know about the Git system doesn't know about them. So we need to add them. The way you add folders is with git add data. And you can add, start adding files or folders. What you are adding, that you can hit git status. Every single time that I add in the folder, it will go recursively into that folder and add in the files inside. All those files, which is actually a bad idea what I'm doing here. I don't want that. That's why I did it differently. Let's see. Let me see. This is why I didn't want to do that, because I would like to show you how you ignore certain files. And otherwise, you will get those on the way. So, let me see. I create a okay. So, what I will do is to create some folders. Okay. And create some empty files there, so that and I will add those folders. Okay. If I detect that I have new files, those are notified right now. And so basically, I am adding those files into version control. Every change that I will, from now on, changes that I start doing on those files, I can keep track of them. They will take the difference of those files. If I change something in a line, you can go back and reverse changes. So you can know who changed what and where. So let's continue. Okay, yeah. So this is how it works. Right now, I ask them to be part of the version control, but I have not created a checkpoint, like a checkpoint on the system. To doing that, you have to commit them. A second. Okay. So I have created a commit. Think about that like a checkpoint where the files have been acknowledged to be changed in a version, right? You can see those versions with Git and log. So you can see who, when, what was the purpose of that change. So I create my initial commit. So imagine that I'm starting my new project, my new paper, and this is what I will do. I create the places for start working on those things, and create my initial commit.
Can you scroll up a little bit?
What?
Can you scroll up
Here in the here.
Yes.
Up to what?
A little bit more.
A little bit. So
Yes.
here,
Stop.
here, okay. Let's review what I did. Here I execute git init. So I start on a brand new folder. So I will start doing this step by step instead of start filling this on something that already was created. So git init, create the initial. I just to mock some data. So I create some folders, 4 folders here with this touch command. It will create some empty files for readme for all those folders. So I got something, and after that I add those folders, check what happened, and execute the git commit to get my first checkpoint, my first milestone in this, and I check in the log to see what is in there. What was the first change? Okay. Okay. So now this is what I would like to do. Okay. Okay. So what I did was copying. You can do it by hand. You can do it in several ways. Copy the files into them. The reason why I did this again is to show you that, at least for example, for papers written in LaTeX, you don't want to add everything. In particular, you are not interested in getting any version control on this file. For example, this file is created every single time that you execute LaTeX, so you don't want to do this. This log file is also not interesting. So we can exclude that, and that's exactly what I would like to do, exclude some files from version control and keep what really matters. That is this, the paper, actually. Eventually this is something that helped me to build the paper. The plots and the data. This is what I really want to preserve. So if I execute git the status now, I got a bunch of files that are new for the system, that they have not acknowledged to be part of the version control. And it's asking me, well, okay, what do you have to do with them? So before actually add those files, I'm not sure if I can do this, but okay, let me show you that. Something that you can do when you don't want to version control some files and you don't want to see them here is just to add them to an ignore place. So I will add this with a file git ignore. This is because, in particular, for LaTeX, you don't want to keep version control of those. They don't care. In the case, for example, of code, you don't want to keep version control on the output, the output files created during compilation. So
You have to create one git ignore for each.
you have to create one git ignore
For each
no.
folder that you
I am creating on the base folder of this. So I'm working right here, and in this place, in the very base folder, I create this folder git ignore to add the files. I was using those stars to say everything that is end with .log. I don't care about that. And notice that the files are no longer recognized as something that you should add or you want to add into the system. So I want to move those out. I don't want to care about those. Those are created every single time that I compile this, and I will show you how to compile the code. So let's have this git add git add. Well, this is a way of adding everything that you know that is there and it is new. Git add dot. So simple. Git the status. All those files are new for the system that have been recognized that it should be part. And now git commit, let's say, with a message, new data and in paper. Okay. Right? So again, what we did was I copied some files here that are on the repository for data for these sessions. I copy all of them. I create a file here to ignore a few of them. So to ignore a couple of them. So all the 10 with this. and I add them. I execute this as dot to add them all, and I execute the git commit to acknowledge this new change and create a new, well, this command to get a new point here, a new position. So if you execute git log, now I have two commits. Now let's do something. Let's go to the paper. PDF. Let me see if that will work. Paper. Okay. So the paper is very simple, but if you are not familiar with LaTeX, it could be scary. This is like with text file with some special commands, and that will focus you into adding the content, and the format follows what the journal send you to create a paper for it. So, but not all the disciplines work with this, so I will skip this time. So you got a different paper PDF. You got a PDF. Maybe I can show you the PDF how it looks like. Yeah, PDF is, or right now it looks something like, well, this is what I see when I try to execute this with display. It has more space here, but basically it has some title. I put the plot here, an abstract and a figure, and it's very simple. It's a mock, but really is. So right now I see that Git status have a new change, because the PDF has changed a little bit. It's slightly different. It has probably a different date, creation day, and was compiled with this version now of PDF LaTeX. So it's different. So this is the opportunity to add this file, to commit this file, to add it to the stack. And right now, if I execute the status, the file is stacked for committing to be part of the system, and I get commit understand new PDF. I will skip some part of this. You can follow. Okay, this was the ignore. If you want, you can ignore the PDF, because all that you need is sources to create the PDF. So you can skip that. All that it really goes into the sources or whatever you want to do is what really matters to keep. Okay, so this is what happens. This is a procedure to remove files that you don't want to track later on. So I will skip that part. And the exercise at some point here was to modify, I think, a little bit the script here to change the function to get a different function. So you get a different plot, and eventually you will get a different data. And so instead of sinus, it will be a cosinus. Well, so you change the data, you will change the plot, and you have to commit some files and do that. I will probably will not do it. I have some other things to show you, and also probably will skip this. This is a little bit more complex exercise, where I have, well, like probably this one. Start showing more. This comes from a different place. So I have on a small repository here for code. If you are, this is what you actually do when you are working on GitHub and you got your repository. The only thing that it changes is that now the final repository is in somewhere else. It's a different machine. So there are a couple of commands that are new. Well, this is one. There are actually three. Clone to get the contents of the repository. It will download the code and give me the. This is exactly what you did for the data hands-on. And in some way, what you see here, all this is actually a repository also in GitHub. So all this was created with the same infrastructure. So I have here a code. This is more for developers, so I will not enter in too much detail. Where you have a code that needs to be compiled. But module blank GCC. So this is how you develop code, and this is an exercise on AutoTools actually. How to recount Microsoft. So this is how you make, configure. It's detecting the compiler and make, and you get the code, and the code is right here, I think. So it will do this. It will show the version. It will. So it's the entire development on a tiny little piece of code that will execute something. So this is something that is in a, but it's actually asking me for 2 numbers, and it's telling me which is the biggest one of those. Anyway, so every single time that I change the code will be the file will be modified. I commit it, I add it, I commit it, I can push it if I want to. Yeah, no question.
So I see here in help that and
on the documentation on the webpage.
You can have Git checkout so that you can go back to another version that you have.
You can, no, the checkout is to revert the file. For example, let me show you what let me see to make the difference on that. Git status. Okay. Okay. Imagine that I will change this. I will screw this. The main C. So I will introduce a bug here. I will delete the semicolon. So of course now this file, if I can still configure, but if I try to make clean, I need to clean this. If I make, it will fail. Right? Someone screw the code. And I can go into Git status and see that the file has been modified. And actually can see how that file was modified. How this. And I can see the difference. Okay. Someone removed the semicolon, let's say imagine that I have my students and one of them screw the code, they put something and make a bug on the code. So first I know who to blame, and second I can revert it. So to revert that is git checkout. And the file. So, and if you check now, the branch was back to normal.
How I choose, like, I have a, like with git log, I have a lot of notifications, right?
Yeah.
Can I choose one of them?
You can choose one. Yeah, you can do far more things that I now attempt to show you. But yes, you can go back, check. You can go really early in the development and see what the code looks like. Take something, and you can merge. If you have several students but you don't trust them, they are just learning. So what you can ask them is to have their own fork. So forking the code to create their own branch. So they work on that branch, and instead of give them permission to commit into your branch, into the main branch, you just tell them that they have to asks for merging. So merge request. So you check that what they did makes sense, and you merge it. You took the control of a gateway, and you control that. If you trust the people, yeah, when the projects grow, you don't trust anybody, so you have someone who is in charge of testing, and you have tests, you have a test suite, and you have to prove that the code still passes the test before you merge, when you start doing these things seriously on this. Okay, so that's what is missing here in this lesson is the execution of these commands, git push, git pull, when you want to take the data down and put the data back into the system. And here I put a few places where you can learn more about this. I didn't devote more than 20 minutes to show you this. And just this is for you to know that as a faculty member, you can request a private repository for you and your students, and some professors do here. So let me see what we'll do here. That's the last thing before we move to lunch. For lunch, so let me see. I'm not the most expert on this, so I will skip the. So if you want to transfer files from your computer to your to the cluster, from one cluster to another, probably the best and most efficient way of doing for large files is using this Globus Online. The expert on that, and if you have issues with that, Daniel knows about that far more than I do. It's basically a web interface. Let's see.
Let's go to lunch.
Yeah, let's go to lunch. So let's skip that. And there is another way with this FTP. It's kind of not very friendly. But yes, you can move files between clusters. You can move files from Spruce. It's easy. You can move files directly. With Torny, we need a little bit more. You need to use Globus somehow for transferring files. So yes, it's possible. It's there. The documentation is there. And another thing is that we're using Globus, using this service. You can also attach your Google Drive account. If you have a mixed account, you have Google Drive, and you have unlimited access to unlimited storage on your Google Drive. So some people store terabytes of data on Google Drive. It's for free, so you can use it. The only thing is, it's a little bit slow. But yes, faculty has options. So anybody with a mixed account has access to this Google Drive, and you can transfer files from the cluster directly to your Google Drive for cold storage. Consider that a cold storage to store and forget. So yeah, and we will return. What time we will return, Nate? 1 hour. Yeah. Huh?
You're gonna go through these after lunch?
No, probably not, because I have more other things. I will just mention this. I will probably not have time to demoing or showing you that, because we took a lot of time for the singularity, so I need to compensate somehow. So just to show you that you have that service to files.
But just a question: can I map my Google Drive on here?
Yes.
Can I see it?
Well, not for the training account, because the training account has no mixed account, but you have a mixed account. You are faculty, so you have mixed account, right? You have a mixed account.
I have a mixed account.
So you have a mixed account, you have Google Drive, and you can transfer when you have your.
But then I'll see a folder on Google Drive.
No. You will see a place.
We can go to that. If it's worthwhile,
Yeah, we can. The thing is that I cannot allow you to play with that from your training accounts, because the training accounts have not Google Drive.
Showing ours, because this is, I think this is very important.
Okay. Yeah, we can devote some minutes after lunch, so, and I can show you that. Yeah, no problem.
Just mark your name off that. Pause the recording. Yeah, I think they're going to get off around this, the maybe the committee and then
To put more effort on this, that
maybe.
the next time. That's why I would like to see the people telling me what really matters to them. So we enlarge those portions.
All right, we'll get started. Me and Dana are going to cover this section. It's about file shares and transferring data. So there's several different ways we can do this. Dana is going to show Globus Online, which is a service that actually is free, but we pay for some additional benefits of this. Mainly the ability that you can share data on your own to anybody you want without contacting anybody. So if you're working with a researcher at a university, you want to share data with them, and you want control access, we have to rewrite all that stuff. We're not going to get all that, but we would have documentation on that. But if you have issues, contact us. So you can share that data easily without ever talking to anybody. I say that with caveats. If you don't want to restrict the data or HIPAA data, you need to talk to your IT department. What Daniel's going to show first off is one of the cooler features we actually pay for is a connection to Google Drive. So what you might not know, if you have a Mix account, you have free unlimited storage in that account. Problem with that is how you get your data there, especially large data sets. The client on your PC, whether it's Windows or Mac, they don't have a Linux client. That won't upload large files. And the web interface, you're limited to several gigs. But actually, Google Drive can handle 5 terabyte files. So if you have one file that's 5 terabytes in size, you can upload it. We actually have researchers that do that, believe it or not. So what he's going to show us how to do this through Globus. It's all point and click. He also has a video on this. He's recorded. It's on our documentation. So after this, if you don't remember how to do it, don't worry about it. We can point you to that video. But after he shows that, I'll show you some old school ways of doing it that most people still use. This is the preferred method for most things. So y'all when you're done.
All right. Okay, so first you're going to log in with your WVU account. So you come here, it'll ask you to select your organization, select West Virginia University. If you're not from WVU, you can select other universities to connect. And then, so once you're logged in, this will be their home screen. You want to come to this endpoint section here on the left. And then to connect to Google Drive, the endpoint name for it is W Google Drive. It should come up there in your search. Click on that, and then sure.
Please.
No problem. So let me know when you're caught up.
And you won't be able to do this with your trading accounts. So
I'm sorry.
you won't be able to do this with your trading accounts.
No, you have to use
Your W login.
Okay. Okay.
So once you're there, click on this collections tab at the top. And say add a collection. And then it's kind of the same thing as when you originally logged in. Then you'll get these two options. You want to choose the top one, the Google Drive Storage Gateway. Then if you get this, you're missing an identity from a required entity provider. Click this email address down here, bottom, continue, and then enter your Mix address.
So we have the mail.edu.
You have to use your Mix.
Yeah, it has to be Mix to get to the Google Drive. Yeah, but you can put both. So you can sign in. You're signing in with your W login, and then you can link the Google Drive separately.
Now you need to do this too. And I'll get up here so people know. You only need to do this if this part for Google Drive. And also, Globus also connects for our HPC systems, and you can transfer data between that and your workstation without doing this step.
And I can share that as well.
But this here is just for linking. This is required because actually this is connected to Google. Google actually does all the authentication, but we're linking those two accounts. So this is what he's showing here.
So then after that, you'll get a confirmation code in your email. It's going to take me a minute to type this all in.
Technically, could be any Gmail account.
Nope, that's the next step that we got to do.
That's
It's not working with it.
So all faculty has these accounts.
Yes, all faculty and staff can get them for free as well. You have to request it for staff. Students get it by money.
And so once you've put in the confirmation code, you'll get this screen. The only thing you need to worry about here is putting in a display name. Doesn't matter where it is. The rest of that you don't have to worry about, but you can mess with it if you want. And then hit create collection.
So I had another screen. Rest of account. Global.
Oh,
After I put my documents.
type it in here.
That's it.
Probably skipping a few steps for games. I've done this before, and I'm right. Did it all.
So this is maybe you choose.
Yeah, so back there, all you do, you can leave most of it as the default and just enter a display name for your collection, which is what you'll search whenever you want to use it. And then here, you can add other identities, but we just want to go to transfer data, so I can show that real quick. So now this is showing all the stuff I have uploaded on my Google Drive.
How you get there?
After you're finished, there'll be a couple options. One says transfer data, or you can just click on the Globus home button at the top left, and it'll take you back here anyways.
So you see got a bunch of years. So another thing you can show real quick is basically what you want to use this mainly for is archiving data. Google Drive is really good, like I said, for archiving data. It's not good for active research, but I mean, it's slow. So if you're working on larger data sets and you're processing over and over again, you're not going to want to mess with this. But if you're going through data, you want to make sure it's preserved and kept it, upload it here. And like I said, we do have videos on how to do this, so don't get worried if you miss a step. These will show there, and then if you click next over there, transfer to Spruce. Yeah. Or the data depot, either one's fine.
So if you type in W # and then there's a few different endpoints. So Thorny DTN for Thorny, HPC DTN for Spruce, and then Data Depot as well.
And this is when you're uploading into your collection or dumping down.
You can do either way. You can go both directions. So now what I would be doing here is I'd be transferring something from Google Drive to Spruce. So this is showing my group home and Scratch for Spruce.
Just Spruce is on the right.
Yeah, and then you can flip those too. It's just whatever you want to do.
Yep. First. And then from here, you can, if you need to, you can create a new folder in your Spruce account to place stuff in. You can select individually what you want to transfer over. So if I want to transfer these three things, I can do that.
So Spruce is called HP.
W # HPC DTN.
Nice.
That's on the docs too. So don't worry about memorizing those. It's might look a little complicated, but once you use it, literally for a half hour or less, it's real easy. Guillermo, he'll admit this, he hated it at first. Then he used it a couple times, like, oh, this makes a lot of sense, right?
Yeah.
So,
And they have improved the interface, the way they.
Yeah. So once you're done selecting that, you hit start down here at the bottom left. It'll give you a submission ID that you can check, and it will show you the status of the transfer, if it failed, why it failed, all that stuff. And it'll also email you if it's successful or not.
So the cool things about Globus. Go ahead.
No, I see other people drive.
Yeah, you can't transfer to them, but they'll show up in the search.
I cannot win.
No, you want to push it to them. The last they opened them up, that's back to you where you're allowed to share your data and set permissions however you want. But by default, it's locked down just to you. I'll have to check that. That might do something.
And you can create endpoints to your own machine.
Yeah, because I transferred something that had the same, that I already had up there.
For your machine.
So a couple other things that is neat about it is it does verify the integrity of all file transfers, especially large file transfers. They can be corrupted. So that's not a terabyte file. It only takes one little bit, makes the whole thing wrong. It also does automatic restart. So if you're in your lab and you start transferring terabytes of data, then you want to go home because you don't want to lay around with your laptop. Close your laptop up, take it home, so you open your laptop, and go home and start transferring again automatically.
I can go through real quick how to create a personal endpoint.
Yeah.
So if you want to transfer something from your PC to Spruce or to Google Drive, whatever you want to do, go to endpoints, click create a new endpoint. You get these two options. You want to do Globus Connect Personal. Then enter a display name. I can do whatever. Generate a setup key down here, and you'll need this later, so you can just copy that. And then it's got instructions for Linux, Mac, or Windows.
You can try mushrooms on this. It'll work on your laptops, but we don't have admin rights on these things. So we'll see if it actually lets you get. So we're not allowed to install it, but that's basically all you do. And what happens to the next screen? When he does this, it's going to ask you for that key, and just enter that key, then you're done. So that your endpoint name, go back to your endpoints on the left-hand side, click My Endpoints. It'll show up there, and you can just transfer it to your laptop or desktop, whatever you want to.
So you can do desktop to desktop.
Yep. Now the desktop is actually something we pay extra for, but so if you went to another university that doesn't have this, they will not have that.
So this is just because we have WU account or not?
Yes.
It's not free for everybody.
Parts of it are. Parts of it are.
This is not like from PC.
PC to I guess this is where it gets a little confusing. PC to a managed endpoint, which is terms they use, like a big shared file system. Yes, but if you're going PC to PC, what we call personal endpoint to personal endpoint, can't do without being part of WU or a university as part of the subscription. Some labs really like this because the professor likes to share files with 20 of their students and then share them with their download them off of that. If you get stuck or have to actually come to your lab and or in classroom, you're going to talk one-day classes in classrooms, we'll learn this stuff. If you guys ever have that, want to come out and do a one-day or review any stuff in front of the day or any topic, as long as we have the knowledge on how to do it, we're happy to do that as well. But a lot of the stuff is actually in our documentation. So.
And you can even, I know like you requested an account on Spruce and Thorny yesterday. You can transfer between both of those. So you can transfer data from that you have on Spruce to Thorny. Makes that process a little easier.
And if you have let's say you have students and you're sharing with them something, and then they graduate and lose their Mix account.
They won't have access to it anymore, but if they have, so if they're at another university, then more than likely already have access by default. Almost all R1 universities will have access to this. But if you also have a Google account, all you need is a Google account to get access. They won't have all the features, but you can share stuff with them. So if you have a personal Gmail account, you can actually share stuff to that person. Back when or you can create a Globus account themselves on your Google account.
And then all these notifications will come to my Mix account or the
Mix account. Well, it depends.
They'll come
That's where it gets confusing. Depends on how you link your identities.
Like the way I have it set up, it'll come to my mail account.
It's your parent account.
Yeah, to my @mail account, yeah.
Having two email systems is a pain. So, If you got one to one, up to the other, just got this.
So now I'm supposed to see my new endpoint here.
When you search for it the first time, no, you have to go to your collections. So when you're sitting here, it won't show up in recent because you haven't used it yet. So you just go to your collections and it should show up.
Your collections is cool because it'll show every collection that's actually.
I see now. Oh, that's very. But it's not storing anything, right? It's just.
No, that's one key thing we want to make sure about Globus. Globus does not store any data at all. The other thing it does is manage connections to data sources. So the data sources can be something we have, can be something in your lab. We have some people that run this in astrophysics have their own storage system where they have a big storage system on petabytes, right? They use this to transfer data between your bank. But it's all for transfers. Actually, they don't even see the data. Always don't send out the connection. They don't say your username and password either. As you notice when you're logging in, you saw a W login prompt that looks like very similar to what you're using your email. All that stuff's coming to W. It's all done with back end certificates. It's magic.
There's no two-way authentication and all that stuff.
There is.
Yeah, when you sign in.
When you logged in, it's just like you didn't.
I had already signed in
You
earlier,
already signed
so
in earlier. So if you already brought up a mail account, you've been within 24 hours. You won't have to do it. Now the transfer to the back end doesn't. That's all. And so you can close this website and that transfer can be more than 1 weeks. It doesn't matter.
And the transferring could be encrypted, right?
It depends. By default, on some of them, it's not encrypted, but you can click to encrypt it.
you have the option when you link your base account to do that.
Yeah.
I don't know if you can change it afterwards or not.
Um, HSC actually is looking at buying this for people at HSC for some HIPAA data. There's another thing it's called high assurance something. I can't remember what it's called. But all that data is actually encrypted by default and has some extra restrictions on top of it.
So they don't want you to use this for PHF.
No. Well, you can. You have to do it through Laura Ross. Contact her. They were looking to pay for it. I'm not sure if they did or didn't.
And then just click on a file and start, and then
Yeah.
that's it.
That's it.
But it's not there. So it takes. Okay, maybe. Yeah, it's there.
And you said that it doesn't store it, so what does it do? It doesn't store it. So the person has to take it out of there right away that you're sharing it with, or?
No, Globus, all it is a transfer tool. Just like I'm going to show you some old ways of transferring data.
Let's say the analogy that I imagine is that this Globus is not a mailman. It's more like Google Maps to tell you where to start and where to go, and they give you the route. So it indicates the route where the data has to go to one place to another, and the data has to go from a storage place to another storage place. So
But then other
they don't
storage
control
place-
the actual package.
But then, what if the other storage place is not hooked to internet at that moment? What happens? It just
It
stays.
will stay
And
slowly
runs.
waiting.
It just waits. So like I said, if your laptop is your storage place, you shut your laptop, you go home. Obviously, you don't have internet in your car between your house and work. It's just going to continue to try to send data. It does a check-in every 60 seconds or something like that. When the connection comes back, it starts sending data again.
So when you get to this point where you name your collection, you can choose to force encryption on transfers to and from it.
It's off by default for most of these people curious because there actually is. Now, there is some overhead and slowness to doing that. Most researchers are doing open research, so they don't care about it being encrypted. Nothing they're doing is sensitive. It's totally up to you. Some people want to encrypt it. Encrypt it if you want to. Don't encrypt it if you don't want to.
You got a message.
Look,
Here, you click here and you see what happened.
I got the message.
Okay, you got the message. And they say succeed, and the size, one file, this.
Yell me if anybody has questions. Okay. There is one person over there. I think he's. So that's all this transfer files, and we do have more documentation on this in several locations. One thing we need to do better is consolidate some of our documentation, which Guillermo and Daniel have been working on. if you go here in our documentation, most of this is laid out here and describes it pretty well. But if you have any questions, yell at us, and we're happy to go over it. So I'm going to go over some old, it's not really old because most people still do it this way. Transferring files with the command line. So there's multiple ways of doing this. I'm just going to go to show two. There's probably 20 different ways of doing this. These are some of the most popular. You probably heard of FTP. If you've been doing this for a long time, a lot of things, FTP is still around. That's kind of been replaced by SFTP, which is secure FTP. Actually, it goes over secure shell. So that SSH command that you guys have been using this whole week, today and yesterday, actually transfers using that exact same protocol and system. And we're going to go over some of this real quick because I know Guillermo's got quite a bit to do. This is really easy, and this tutorial is really easy to follow. So I don't think anybody's going to have any issues with this. The syntax is really easy. It's just SFTP, very similar to what you were doing earlier. Your username and a remote computer address. When you get in there, you type help. It gives you a lot of things. Actually, there's only like 2 commands you really need. There's other things here you can do if you want to do more advanced. The majority of the time, you're going to just use 2 commands. And we'll go over those here in a minute. But it's put and get. Once you log in, you can type PWD, tells you your current location. And you put if you want to put a file, so put a file that you have locally, you want to move it to the server. And if you want to download it, it's a get command. And I'll actually go through this interactively here in a second. So one thing we do, we have a little VM set up for you guys all to mess with. And if you actually type in the exact same thing I'm going to do, I'm just going to go to my home directory and type in SFTP training at 149.165. And I won't go anywhere until you guys actually got this typed up. 26. This will log in. Can everybody see that? I know I typed it down pretty low. And Daniel, if you don't mind, just retyping that on the
What's
chat.
the number? That's the address of the.
Yeah, so this is an IP address. What you've been typing in all week is actually called a host name, spruce.hp.edu.edu. It's actually going to another underneath the covers as well. This test machine is actually at University of Indiana. We have access to some of their systems. So it's actually going out there, and we're just going to connect there real quick. It's going to prompt you, do you want to do this? And it's the same as you saw earlier with SSH. All this is saying, hey, I've never connected here before. Are you sure this is okay? Yes. One thing I do want to point out, and Guillermo might have pointed this out earlier, if you get this says error, I can't remember what's supposed to say, invalid cert or something like that, and you're not expecting that, that means something's changed. You probably want to contact the person that manages that system. So if you ever connect to Spruce and you get an error after the first time you hit yes, that means something's been changed, or it might be some kind of hacking attempt going on. This doesn't happen, but I just don't want you to be like, something like that shows up, yell at us so we can look at it. And the password is this HPC capitalized 2019. Nice and simple. Capital HPC 2019. When you get in there, you're going to see a couple things. You'll see desktop, which is actually the home directory for this. You'll see a class directory, and you'll see a new.config. Everybody see that? I'll give you a minute.
For you, for I'm not following. HPC, no, it's HPC. Uppercase. LS, you can execute LS. Exactly. You will put instead of your name here, screws or thorny or something like that. This is screws that works for screws and thorny plant.
What's that?
There is procedure for connecting
Should work from anywhere.
from anywhere.
But then,
To bring files from those clusters back.
but the password.
Capital HPC
And the
2019.
password will change.
It's I didn't put them. Is this capital HPC 2019? It's not.
And so he is doing the exercise with different machines just to allow everyone to see exactly the same.
But if I was on my own account.
In
I
your
would-
real case, in the real world.
Password is this.
explained by your
I'll put it on screen.
Actually,
It's not that.
or Dorothy.
I can't do that though.
Yeah.
That's the password.
Your password.
Once you're in there, you're going to see a couple things. You can move around in this like you're used to. You see it in class. You'll see there's a bunch of files there. These are just files that I created. Nothing's in them, but let's say we want to get file 60. It just means get that file.
So it's transferring the file from the remote place to the local.
And you'll see down here it says fetching. It's going to store it locally as file 60. So what I'm going to do now is exit. Actually, I got what I needed. I don't need to do it anymore. You'll see, if you type ls, you'll see a file 60 there. There's actually nothing in it. Now I'm not going to show it just for time's sake, but you can do the exact same thing. Let's say you wanted to put the seer.c up there. You can act just like I just showed you and just simply type put seer.c. So we'll show something similar to that. The other thing we can do is secure copy. Secure copy is non-interactive. What I just showed you was an interactive method for transferring files. It's going to do the same thing. We actually want to move, let's say, seer.c to that IP address I just gave you. So we type seer.c. We're going to type training, which is username, and the IP address. And the thing that's a little bit different on this, after that, you guys say where you want to put it. If you just put this slash, it's going to put it in your home directory, which is what we want. But if you wanted to put it in your temp, you just put type temp. Same password as before. That's because I don't permission to.
Fetch this file, right? This is like, make this file.
There you go. Don't put the slash then. That was my fault. You just want colon for the home
This
directory.
uses SFTP server.
No, this uses secure copy. It's using SSHD.
Not a server.
Well, actually, technically, it's a server. So Secure Shell is running a daemon on the back end. So there's two parts of SSH. SSH client, which is what you've been running this whole time. So SFTP, CP, SSH are all client commands. On the back end, there's actually a daemon running. But all a daemon is these service running on the Linux machine. And it is SSHD, the actual process. Most users will never have to worry about that. So for our systems, we manage that for you. And this is all running. Most of it runs out of the box. This actually, when I spun this up at 1 o'clock. It was just turned on by default. So basically now this seer.c is up on that server. You've done all this with Globus. You can also use command line. Most of the time I do everything command line, but I do evangelize the benefits of Globus. It's really up to you guys. For Google Drive, definitely use the Globus because that way you're going to get large amounts of data up there. There's a couple of commands, I'm not going to go into them, but just so you're aware of them. And I think it's in documentation. rsync, a lot of people like using it. It's very similar to SCP. One of the main advantage of it is it only transfers data that's actually been changed. Similar to Globus, but it's on the command line. It doesn't transfer in parallel. Globus actually transfers files in parallel. I don't think there is, and German might know this better than I do, but I think there is some forks of rsync that actually will transfer in parallel. I thought you used something.
Yeah, you mentioned something.
But Google Drive, I mentioned that there. Of course, if there's any time you want us to go over these things, I'm just not hitting those, but they're kind of redundant. That's why you at least, if you ever heard the word rsync, that's what it's doing. Same syntax as SCP, this has some different advantages. Any questions? Anybody on chat have a question? In? All right. I know that was real quick, but let's take a 5-minute break, and then we'll do the last section, and I'll hand it over to your message.
So because wherever I am.
And the moment when you execute the command for it. Yes, it's a trusted scan.
But then probably, so if I wanted to change it, put it somewhere else except
You probably need to change
there.
I see. All the commands will start with L and local. Yeah, the other commands are remote. So execute this thing, and now you are not Git, but one folder up.
Oh, I see.
So I think you can do something like this. Like this. Now I'm
So like when you use this LCD stuff, I think you folder up.
on folder up. I was Git, and now one folder up. And put it up now. I am here through this machine. I want more folder up. Where I am now. I am here data hands-on. One folder up. Where I am now. Your home folder. You transfer in. You transfer the file to your home folder.
And it should show.
Probably you need to reload refresh, and it should be here. Yeah, it's pretty because you have to reload it. So
There's really not a third parameters. They're from here to here. You just set it up by standing where you want it. Sort of positioning yourself where you want it, and then send it from there.
and same thing for setting file, for example. Set that.
That was that easy.
Yeah.
So just put it on, send it there.
It's just it's very common line. It's very old-fashioned. But
I gave you 5 minutes until you started.
oh yeah.
3 more minutes.
And there are graphical clients for FTP, right? For
Yeah,
Windows.
FileZilla's one, and SCP's another one.
Those are
FileZilla's open source.
FTP client. Another, yeah. Do you know if the Mac has FTP client embedded? Okay.
But I don't know if there's something.
No, they say like mounting like a drive or something.
Linux does, I don't know.
So like if I have data like from Illumina, from Subgenomic, or if I want to upload that to my.
Download it. Download. So you have, for example, you have an account in Illumina or something. So they give you the instructions to download that by command line. You can download it directly to Spruce. So look, what more researchers do in that case for that is that they give you like an access in a web page or something, and people download that, and after they transfer from the local machine to Spruce for.
So why would I need this SFTP? What is the advantage of SFTP?
Because for at least for Thorny, that's the only option. Well, except for Globus, right? But if you don't want to use Globus, you have to do this with SFTP to transfer whatever you got from Illumina to Thorny Flat or Spruce. You know what I mean?
No.
Let me see. Let me see.
Because I wasn't listening.
Oh, okay. Let me see. It's better. It's better.
That is an erase point.
But we don't have.
It doesn't erase.
It's permanent.
No, I tried erasing it.
Okay. So okay, let's mimic this. Let's mimic this way.
I can try with this.
Okay. So imagine. Let's make this like this. This is Illumina. Those are their servers. You ask for getting the readings here. You get this, and they send you a mail or something. Where okay, you can take the data now. The data is ready for you. Download. So one thing is that this is your client. This is your computer as your desktop, and you can download the files from here to the machine. And imagine that this machine here is Thorny Flat or Spruce, and from here you can transfer the files with SFTP to Spruce because you need to recompose the genome with that, right?
And if let's say I don't have enough room on that machine to store it all, it still works.
So no, you have to restore it. That's why this is option. You are doing double job. You are transferring the whole thing here, that could be big, and transferring from here to the cluster. But if they give you the access, and I think they do, you can directly transfer the file with SFTP directly from Illumina to the cluster without having an intermediary. So that's the nice thing. And I think they do. They think the Illumina give you that access.
They do. Are you working? You work with Steve Fazio?
No.
Yeah. What college you in?
Agriculture.
Davis? Yeah.
Davis. But you get your data from the genomics core, right?
Sorry.
You get your data from the genomics core. Is that what I heard you say?
No, it's a company. It's not a company called Illumina that makes.
Yeah,
so
I thought you said genomics core.
Yeah. Genomic. They did the analysis, but then they're sending it through the sequencing.
See, that's under Steve DeFazio. It was under Steve DeFazio's group. He can have that set up and go straight to you if you want to. But yeah, most researchers have to sit to our lab and they upload it again.
But if it goes straight, then we don't need the SF.
Well, it has to use SFTP to get it there.
Oh, it does. Okay.
The question is, do you want the files to be transferred to a machine and later to another machine, or you want to transfer directly from Illumina those are big files and send those directly to the cluster where you will actually realign those things? So it's probably much better because those files are big.
So either way, I would use
either way, you will use this SFTP or yeah. So I was checking for this. I was searching for this. If you want to do it in a user-friendly way, there are SFTP clients for Windows or things like that, where you can work with that. What I was also trying to do was to see if I can do this, and I think they do.
Shannon?
I was trying to figure out if I can do this from Mac. Yeah, just burning time from showing the actual shell. So don't be scary about the shell scripting. It's not super shell scripting. It's actually a small thing. So let's see. We will not be learning how to program shell scripting. That's the first thing that I'm going to tell you. We will show you the minimal amount of information that allow you to do useful things for research. So I will have to teach you a couple of elements on this, but what I really like to use is a couple of commands. This is called awk and grep to extract data from text files. This is what really is important. So they mentioned what nowadays the only people who really learn shell scripting are system administrators in the old-fashioned. So old-fashioned system administrators. But many people just simply move to Python for most of those things. So this is the first thing that you will see. You can create, let me see, you can create this. We did this the very first time on that we start this with a greeting script. I will create it. So this file looks something really close to a shell script, except for the first line that is missing here. And you can execute this if you declare directly a shell for it, and you will get the result. So this file, I will put it again. Let me see. If you execute this under a compatible shell, you get what you expect. By compatible shell is because you can use this. Do we have dash here? Yeah, we have dash. We have bash. And this is so simple that probably do we have corn shell? Yeah, we have corn. All those, there are different shells. And I was trying to use even bash. So bash. The only one that scares me a little bit is if I execute this. This is something that basically any shell works with this. So this is a shell script.
The default is bash.
And the default, let me see, my environment, my shell is bash, I think, right?
It's bash for everybody.
It's bash for everybody.
It's like $100 shell.
Echo dollar shell. I was trying to.
Capital shell.
Yeah, it's been bash. That's my default. That's the default shell for this user. It doesn't mean that I have to use that. I can change to core shell. It's a different shell, and I am inside a completely different shell that has its nuances. It behaves slightly different. So one thing to learn is that there are several. A lot of things, they work very similar. Probably the most different is C shell, but most of them work very similarly. And you can change. You can use a different one if you want to use. Bash is what most Linux distributions provide you right away. And this is, wait, let me see which is message. This one probably points out. Oh yeah. So for example, in the case of Red Hat machines, bin sh is pointing to bash. In the case of Debian machines, Ubuntu machines, sh points into dash. It's a different shell. And so the default is slightly different. But anyway, so when you want to remove that ambiguity, all that you do is nano grid and add one extra line here with what is called a shebang. So this couple of bytes allow me to declare to the shell script or to the script that I would like to use a very specific shell script, bash. That I will be using the kind of things in bash that are not in other shells. With bash, you can do quite a number of things that are, especially with loops and conditionals, and some special way of manipulating variables, extracting portions of variables, or the concept of the variables that are not in other shells. So, and this is one thing. Let's just. Yeah. So at this moment, this is becoming better. It has bash in front of it, and there is just one, and I still can execute it, but I need to declare this that I would like to get this interpreted by bash. So I have to put bash in front of it. I cannot execute this. I got the permission denied because this is not a shell script executable. So this file is just for reading it, not for executing. So during the first day, yesterday in the morning, I showed you this, how to convert the file into an executable one. And at that moment, you can execute it like a command. And I have to execute it this way. If I try to execute it this way, it worked, but it will be executing the grid that we created yesterday that I put it in the bin folder. This is another thing. This is a different grid. So as it's not in a location, yeah, I have to declare the exact location of the script for this to work like this. So that's the first thing. So we add this, we show this. You see that there are different, not only shells, but also different shebangs, so different magic words that you can add for different interpreters. In particular, this one is a shell. This is the generic shell of the system, whatever that is, whatever the distribution set us for that. This is the particular bash. This is Perl, which is a language that was very popular many years ago, but it's still used by people in bioinformatics. And there are a lot of things written in Perl that are used today. TCL is another language where you can create windows. It's actually a nice language. And we will use this one, Hawk, for doing a couple of nice things, fancy. And this is what you use for Python. Python 3. This is actually the good way, the Pythonized way of creating Python scripts properly. So let's review a little bit the kind of things that you can do and you cannot do on a shell script. So let me see, I will do this. So I can follow this. Okay. Okay, first, comments. And now I will work on them right here. Let's say, Oh, no. Okay, everything here is a comment. So, like Python, use the same thing for commenting in Python. You can execute, let me see. So this is also a comment, and I use a lot of the time when I would like to create something like this, put the comment at the very top. So I comment the thing and put it there. So those are comments. If you put that in a shell script, if you put that in a script, it doesn't count. I can execute several commands in succession. So for example, I can execute PAW and after date and after that host name. All of them are executed one after another via this semicolon. So it's something that you can do. Semicolon, and you can put stick commands one after another. There are a few commands for escaping special characters. For example, this one, if you execute it this way, if, for example, it will not work. It will just print this. But inside shell script, it will work like this. The V is making a vertical skip in preserving the horizontal skip. So you write, then you move, and you move, and you move. There are another one, if you want to see this one, it works like this. It just makes a new line, new line, new line. And this one just add some tabulators. It was like separate with tabulators. So those are escapes. So another thing that you can execute. So this one is a small example that we'll try to copy it here. Let's see if I can. Let's show you a little bit. Probably don't have to do this. I have all of those here. So, so this one was. This is one example for. So I can start showing you. Example one was this, what I wrote first. Example two was this. Now real shell. It was using SH. Example three was this one. Okay. Let me see if I clear it. Executable. Yeah. So notice that I am replacing this environment variable, but by its content. But if I put this single quote, it's not interpreting this variable. So that's the difference between single quotes, double quotes. For those of you familiar with Python, there is no difference between single quote and double quote. And that allow you to put single quotes inside double quotes and double quotes inside single quotes. You can play with that. In Bash, it's not possible. Single quotes are stronger than double quotes. And what else? Example 4. We didn't have example 4. Oh, I forgot. Oh no, yeah. It's simply that I forgot to do this. Example. Okay. Example for this code right here is showing you what those different escapes does. How you make new lines, how you can write a single command in multiple lines, what the vertical tabs, the quotation marks, and some other things. So again, I'm trying to move this what really matters. So the single quoting, double quoting. You can list, for example, all the files that start with example something. This works. So, and this is different from something like this, where this question mark is just replacing one character. So you notice that now I am just getting all those that has one character, different after example, 2, 3, 4, 5, 6, 8. I show you this the first time we start this with echo. That you can do arithmetic operations with integers directly on the shell. So you can create a shell script where you can do these kind of operations that work. Redirections. I also showed a little bit of this the first time. So I can redirect this into a file. The file will have that. I can redirect with appending. So put in a double greater than, and the file is just accumulating that information, that those lines go at the very end. There are commands who make questions. Let me see. Maybe here. I can show you something here. Here. Remember that I did this tutorial. Let's see this. Okay. Remember this one. I create this hello something, and it's asking for a couple of numbers. Enter this, and I enter this, and it told me what is the biggest number. So what I can do is to create an file, an input file, let's say input, and enter those numbers. Oh. So I create this file. Oh. What? Oh, okay. Okay. And I can use that to inject those as inputs instead of having to type them. So there are old programs who will ask for input for doing things. So you can automatize those with this trick. So this is the purpose of this command, this redirection. So it's redirecting the input that normally is your keyboard now from a file. So when they first ask for the first line, it will take the first thing. And then the next question, it will take the second one. It will take all the answers from the input. My code is asking for 2 numbers. So it takes the first one, takes the second one, produces the answer without having to type those numbers one by one. There are things like this where you can chain commands one after another. Let me see a good example for this. Okay, this one. Yeah. So oh yeah. For example, something like this. So I can chain the different commands and do things with them. So what basically I'm doing this. This command basically shows all those lines on those folders. It's cat, so it will concatenate all of them. And this one, when I put this is the word counter. So they will tell me how many lines are in all those files. So you can chain the output of one command as the input of the next one, and after the output of that one will be the input for the next one, and the next one, and the next one. So this is the kind of thing that you can do. Also, you can do things like this. Imagine that new folder. No. It's example. Oh. Okay, I change this. Example. What I'm doing here is forcing only the execution of this command if the first one succeeds. So I'm creating a folder, and if that folder was created okay, I can copy the file inside it. So this is basically making an evaluation. But of course, if the first one fails, there is not point to making the second one. So first command, if that works, next command. And this is used very often in shell scripting. And you can do it also in your submission scripts. You are doing a processing, and if everything was good with that, okay, you can move into the next thing. And if it's not, for example, I need to process the files. If the files were not processed correctly, well, I don't want to delete them. But if they processed correctly and the output was right, I can delete whatever is left. Test. Let me execute this in any script. Maybe I have this. Okay, I have one example here. Let's see, what is this? What is this? So this is how you can evaluate with Bash the entry of two numbers that will come from, that you will show you how they work. So this is how you test which one is bigger than the other. And I am, with this conditional, I'm showing you which one is bigger than the other. So I'm taking a decision based on two variables, which one is the biggest, right? So the way you execute this is, for example, 13, 12, and 8. So that's how, what I'm doing is here, I'm taking the first entry here, this here is what is called $1. And this one is what is called $2 here. So I'm creating those variables and I'm using them to decide which one is bigger than the other in shallow scripting. Again, this is something, this is one of those things that, for example, in this Dash, probably will not, oh, what the work? Okay. I think, okay, I was not expecting.
Try CSH.
Ah, CSH.
Yes.
It won't work. Yeah, it won't work. It's just because the association is there. So CSH is the most bizarre, and our expert in CSH is right there. So I'm not into it. So this works in Bash on something that resembles Bash. And I show you again. I'm trying to go quickly on this because there are far more interesting things, but I need to fill the gap. Is that you can execute in one line on a script. So you can write this in several lines and do all the whole thing, or you can execute it as a single line. So this is just one line. It's actually doing the condition, and in that case, you have to introduce those semicolons for things that otherwise will be in separate lines. And here you have to put this, and you have to put the echo, and here you have to put another semicolon in order to put those one after another. Loops, so this one is okay. Loops work very similar to the way they work in Python, very different from the way they work in C, if you're familiar with that language. Let me see what's the name of the book. Probably have I don't know. Okay. Okay. So what I'm doing here is right here. This looks very, very similar to Python-like of iteration of an iterable for a loop. So this is the Bash, where this is the shell way of doing an iteration and making a loop here over planet. So the variable planet gets a value that it starts changing from this one to this one to this one to this one to this one, this one, and this one, this one, and for each one of them is doing this. So consider, for example, that you receive a collection of FASTA files, and you want to do something. Those are for genomics, and you want to do something for them, one after another. So one way of doing this is having a loop like this. And for every single loop, then you will execute a certain command. When that is finished, you do the next one, and the next one, and the next one, and the next one. Instead of doing it and waiting until that is done, do the next one and next one. So this is one of the ways. Probably not the best for that specific case, but this is what it is. So this is something that is more closely, but still not the same, to the kind of loops that you see in C, Fortran, or those languages. And let's see, this is wild. Right? So what I'm doing here in this while is that I'm initializing a variable in 0, in Bash, you think that there is not a special distinction between a string and a number. Is the ability of certain operations to take that and manipulate it as an integer. So if you say this counter equals 0, it doesn't mean that this is an integer. No. But here I am doing an arithmetic operation, basically. I am checking if this variable is less than 10, and I am echoing a line, and doing something, and every single time I'm changing the variable, increasing the value of it. With this let. There are several ways of updating that. This is one. So again, this is really fast in the way that I'm presenting what really matters to us in shell scripting. And now we are ready for an exercise. The exercise here is this. I will give you some code, and I think that you have it here. It should be. No, I forgot. Oh no, yes, right here. So I will remember you how to compile this, and you don't have to. Module load. Let's see with the Intel 2018, and I will compile this in HPC. Okay. So this is how I compile the code in C. This code uses this. Basically, you can approximate pi by a series, and the series converges to pi. So I can use this to say, okay, how many elements in the series, how many terms in the series I would like to use to approximate pi. If I just use one, it will tell me that pi is 3.2. That's the first approximation. If I use with 2, it will tell me that, okay, pi is 3.16, 23, something. And I can ask for more and more terms in the series. And little by little, pi is converging to the actual number, right? And it's mentioning the error that you are making by that truncation. So the exercise is creating a small bash submission script for the cluster, and I will give you 5 minutes because this is collecting a small pieces of everything that we have been doing, and I would like you to exercise your knowledge from yesterday to get how pi converges with, how many iterations I asked? Up to the first 100 terms. So what I ask you is to make a script, a submission script that will execute this, and after this, and after this, and after this, yeah. And you can use one core, if you can use like this. Actually, this is parallelized, so, but for this small exercise, that makes no difference at all. So, so I would like you to try to use the for loop or the while loop or something like this. Try to mimic something like I did here in a submission script for getting this. I know that it sounds very simple, but if you are learning this for the first time, it's kind of a challenge. So I will give you a few minutes before we move to something else, so you exercise this. So
a question about the shell. So
yeah,
here you prepared it such that it was built in that folder, the introduction folder for this class. But in real life, when I want to invoke the shell, how do I get there? How do I get it?
Then in the real world, what you do is this. And let's say project one. In real world, you create a project, and you are working here. This is your project. You start with nothing. So the first thing is that if you're working in genomics, you are working and you get those FASTA files. So you collect them, and you decide which kind of codes will help you with those alignments, with all that you want to do. So you prepare your environment. If you want to use Conda for that, with BioConda, you will have your environment, and we'll do with that. So that's one thing, separate thing. Now, you would like to do this with submission script. So you will start writing with Nano, my run job.pbs. And you will start writing your submission script. And your submission script is a shell script. So the first thing that you want to do is something like this. In fact, probably you do it once in your life, and all that you will do later is copy and paste and change what had to be changed. You do this just once. It will have something like PBS minus n align one or something, align one, something like that. A few let's say PBS minus L nodes equal 1, BPN equal 4. I say I can use, let's say, you can use some parallelization on this, and I would like to use PBS minus Q standby, right? And now I would like to do this, imagine, for a number of files, right? So at that moment, this is one way of doing it. Actually, there is a better way of doing it. It's with, I showed you yesterday, with the job arrays, where instead of this is one way. Yeah, let's say this is one way. One way, actually the bad one, the bad way. Another one is with this, something like this, PBS minus T, say from 1 to 10. Imagine that you receive 10 FASTA files and you have to process one by one, all of them. So you will add something here that we can, if you want, if you're interested in something like this, we can discuss what it means. It's basically that based on the array ID, it will pick up exactly the file that you want. So you have you create a list of files. Let me see if I can mimic this right here. But this start being very, very specific for a domain. So my files, so this is FASTA f1.FASTA f2.FASTA something like that. Let me see. No, let me see. f3.FASTA. And you can pinpoint exactly the file that you like with my files tail minus 1. Okay. Minus n1. Yeah, something like this. So imagine that you have 3 files. You have a list of files, and you use this variable here to pinpoint the first one, or the second one, or the third one. And this kind of trick, and I will not enter much in detail, will help me here. here to use this PBS, this job array, to create 10 or whatever the number of FASTA files you have for creating an array of jobs that will work independently, but were submitted with a single submission script that will process all of them one after another. So I remember someone who got something like 100 or 200 FASTA files. So all of them with that one submission script went processed at once. It took a couple of days, but she got all the job done. So this is basically the trick. So this is a submission script, but this is also a bash script. So another way to doing this is with something like this, where you have a counter, you decide that you have certain files here, and let's say an echo files. Let's see.
Why is the bad?
Is because here this is one job. So this is one job. So you have to process the FASTA files are big files that you have to align. That takes time. If the poor animal has a very complex genome, it's a pain. So you have to do that, and after you have to do that, the next one, and the next one, and the next. And there is no reason for doing that, because all that you want to do this has no relation with what you want to do with the second one. And there is no relation with it. So why not to use the concurrency, the natural concurrency of this process, and do those all at the same time, in principle, at once. So it's much better. It's much better. So that's why the job arrays is the solution for that kind of thing. There is another cases when you want to process several, but there are relations between them. So all of them has to be done and needs to happen in sequence. So you have to do this, but after you have to remove some markers or that are not interesting. So you have to do this only after you have aligned the first time. Then after you have to do something, and after you have to do an population analysis or something like that. So you have to wait until everything is done before doing the last piece of work. So at that moment, yes, you have to change those things in sequence and be sure that the first one is done before doing the second one, and the second one before doing the third one. So here is where I am telling you, you can do something like head minus n, and using this counter for the files of txt, and grepping and tail minus n minus 1. So with this, you can pinpoint my file will be. File will be something like this, and this is really fast. I'm explaining this really fast because not all the people is interested in this, and how you can get this. This will work, I think, for the first 3 files, and will fail. Let's say what I can do here. It's my files. And I need to make this slightly better. Bracket issue. Okay. So I create some fake collection of files, and if you run this. Basically will start to operate with each one of them. And no, right job. So imagine that you want to do something like align, equal line. This will execute this one, and 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 this one in sequence. So this is why shell scripting is useful. And I don't think that you need too much beyond that to actually doing real things for you. So the exercise is.
I think that. But
What?
you said this is the bad way. So what's the good way?
The good way is the job arrays. The good way is with this that I showed you yesterday here. I will show you the good way for that problem with the FASTA files. That completely independent jobs that need to be done and they don't have any relation one to each other. The good way of doing this is right here in this example yesterday here in job submission at the very end with this array jobs. Yeah, this one. Job arrays. When you receive a variable here, and this variable, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you use that number to pinpoint a specific FASTA file, and you process that file. And so you submit one job, and that job spans 100, 200 jobs that run independently and execute independently. They will take a couple of days, depending on how many resources you get, but you don't care. You don't care. It will be exactly the same as getting 1,000 FASTA files. The same thing.
For this problem.
For this problem, I will ask you to do it in the loop because I will let you exercise the loop.
But it's possible on that one to put different numbers in front of a.out here. On your screen, yeah.
Yeah.
It's possible to put a number like different inputs for a dot, is it?
You can do that. You can do that.
This BPN number will be
Is something that, if, for example, for this, you can make it change. For example, one case, you want to execute something, a test case, and you want to see the scaling of your code with the number of cores to see how good it is. So you can create a submission script where you are exploring the different values, number of cores, and using this variable, PBS array ID, just here. So you can test with 1 core, 2 cores, 4 cores, 8 cores, 16, 32, 64, and see how, as you increase the number of cores, your code start not getting the linear performance that you expect normally. So, well, the ideal scaling. So yeah, you can play with this. But for the exercise that I ask right now was just this. You got this code. You don't have to worry about it. I show you how to compile it. I just create a script that execute this for 1. Change the last number, 1, 2, 3, 4, 5, until 100. This is really fast, so you get all of the numbers. If you later you will to check, you can make a line and see that at some point it will converge into the good value of pi. With 100, you get it. I think you get the answer. So take your time. I will give you 5 minutes, 10 minutes, and we move on to something else. And tell me you did that and you got to start. So, to do it, something that I can do is do it here silently, so you can see what I'm doing, and you got to start. So I got this code, and I compile it.
on your,
What?
where put the colors on your nano? Colors.
Colors. This is VI, probably.
Ah, okay, that's what.
I'm doing with VI. I am changing my little. So yeah, this is this color index.
Maybe the submission script with Python or just Shell?
Joshua. Yeah, as far as I know, yes. Yeah. You can use it to call a Python script later, but the submission script itself has to be. Or do you know something else? You can use a different. Can you change the shell? You can change the shell, right?
Change the shell. I've never tried Python, but it's the good part is keywords standard out. Probably more of a pain in the butt than Python.
Yeah, yeah. Because okay, this is okay because those are comments also in Python. So at that moment it's okay having this.
Yeah, you have to echo that standard out because that's actually.
Yeah.
Key sub is reading that as standard out. It's how the process.
Yeah, and it probably will run under the shell.
I've never seen anybody try it.
No, I've never seen anybody to make it with us.
Welcome to try. You can't hurt it.
Yeah, and you will not damage anything if you try. So I will do an export experiment to see if I did something wrong here, but I think it's okay. And it's on.
So the name, the extension has to be not be S8
For what? No, the extension doesn't matter. For in Unix, extensions have no meaning, particular meaning. Let's say.
Okay.
So I put it, my way of working. This is how I used to do it. My submission scripts are always called run job PBS. But this is because I am old-fashioned, let's say, in doing this. Some people call it run SH of torque something or submission script or something. The name doesn't matter. The extension here is
It's really for you.
it's for you.
Determine what that knowledge.
So I create this. This was my solution to the problem. Actually, so here I'm setting the name pi here. Nodes 1, ppm 4. I'm selecting the training queue. So those 3 lines are for PBS. Those are comments. This is for PBS. I'm not specifying anything special. I just put 4 cores because I will like to see here running this parallel execution with 4 cores. So all those terms, when I am using 100 terms in the series, 1 core will compute the first 25 terms in the series. The second core will compute the next one, and the third with the next one, and the fourth core will compute the next. And at the very end, they combine the results to give me the answer. So for this, it's so fast that makes no difference. Probably a penalty.
Does that automatically display your counter starting at 0?
No. By default, counter doesn't exist. So you have to define it, and you have to define it with a value.
So
this is very, let's say, it's the same, probably the same in Python. If you don't initialize the variable with something.
No, that's not what I'm talking about. It's,
What?
the MPI run
Yes.
occurs inside the counter.
Yes, because I would like to execute this over and over. I would like to execute this with 1 term in the sum, in the expansion, in the series expansion that converges to pi. And now I would like to 2 terms, and I would like to 3 terms, 4 terms, 5 terms.
Yeah, but you're not distributing 0. The counter is 0 to 25 to 1 node, 26 to 50.
This is what is happening internally. It's something that you will not look. So
you don't have to program it.
I was programming that in the code. I will show you that. So this, let's look. MPI C. This is C. Now let me see if I can show you this. Let me see VI. With VI, probably I can visualize this a bit better. Yes, with at least with some colors. This is what is happening. I will explain a little bit but this is not about parallel programming. So I will receive a number of processors. In this case, will be 4. So, but it could be 8, it could be 16, 40, it could be 100, 1000. This is the actual double precision version of pi. Those are some variables here. So what I'm doing here is sending this n, this number, the number of terms that I would like, to all the process. So I am broadcasting that information. This is one thing. This is one function in MPI that is doing this. And now this is the loop that is dividing the effort. So it's divide and conquer. It's dividing the effort of getting all that sum for the different processes. So all those processes are getting a piece of a fixed number of terms to process, and they are computing that and getting the sum. And at the very end, they have individual portions, fractions of the whole sum. And this function here, MPI reduce, will collect all that information and the operation sum. So it will sum all those contributions. So 1 core will compute the first 25. Actually, it's actually not doing that. It's the first core is computing the first term, the 26. The first, the 5th is jumping. It's jumping 4 by 4. This is actually what it's doing. So it jumps, and at the end it has 25, and it computes those terms and get a partial sum. Second core will do the same and get a partial sum. Third one will do the same. Fourth one will. So all of them will get 4 partial sums. And this function here, MPI reduce, is collecting those partial sums under the operation sum, and is getting the value and is computing the value of pi and the error, the difference between the known value and the value that it was computed with this number of terms. So this is inside the C code. Is what is happening. So what I'm doing here, it was executing this, and I imagine that you got this code because there are better ways of doing this, but you are not able to edit. So all the best that you can do is to compute the one, and after with 2 terms, and after with 3 terms, doing over and over and over. It's a waste of time, but imagine that you are not able, that you don't know enough C to do those changes. This is the best that you can do. So the solution was this one, this file, the old file, and you will get all the answers collected. The first, the second, and you see I start with this value of pi, and I am converting, and the values are getting at the end this number of this precision, this accurate. This is what it's doing. This is the action solution. I will show you again what I'm doing for this.
Yeah.
This is what
I had like 2 very good errors in terms of I learned. So I have to change the folder, right? Because
you have to change the folder. This is important because when you execute, when you land in the compute node, you land in the home folder.
Yeah.
If you put the code in the home folder, you are fine.
Then I didn't load the module because I load outside, so I don't need to.
Yes, and you have to load the module because when you execute this, it's a brand new shell, and you have to tell the shell, okay, I need this code. It's the same for everything. If you are using a code for doing an alignment or something, you have to load the module for doing that in advance, during the submission script.
Can I?
Yes.
Can I save files inside my C code? Normally, like, can I write? Can I like create a file inside like open a new file and write my response there instead of clicking on the screen?
Yes, you can do that in the yeah. All those languages have ways
I can
to
use everything.
Yeah, you can do everything. This is the code was written just to put this on the screen, and I just tweak it just to collect all that information. Actually, the actual solution, the good solution for this, is to do it. If you want to see this, is tweaking the MPI, the C code, in order to get 1, 2, the different elements and collect them and see, okay, if you use just 3 terms, this is what you get, 2 terms. Yeah. But this is a completely different problem. So my point is, this is probably why you want to learn a little bit of bash scripting. You don't need to go into fancy stuff for doing real things. Just for doing this kind of loops, or eventually some conditions. If for example, if I don't, I'm using again the genomics. See, if I don't get enough coverage in my genome, I can discard them because this is not good. I have too many. If I have a reference, I cannot align that. I have too many holes in this thing. This sample is not good. I can discard. So I can use a value to discard certain elements for the next process. So for that, eventually you want to use some scripting to filter those that are good. This is good. This is good. This is bad. 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 Tagging some good and bad. Before doing something later with the data in a multi-step process. So you got some good. Oh, now for example, you are training. You are training your network. Actually, several network. Oh no, let's imagine this. You are training a random forest or some. I don't know if you're familiar with that. Some decision trees. So you are training those things, and you train several, and some of them they don't behave good. So you can have a variable or a metric that tell you how good that is, that decision tree is for this case. So you can use that metric to say, okay, this one I discard, this one I keep, this one I discard, this one I probably will prune or something, I will do something with that tree. So for that, you will use conditionals, and you want to do those things inside the script eventually, or do it entirely out on a Python script if you like, but it's up to you. This is something that you can do. So let's move on, let's do something else. Right here. Look at this. This is the output, this file. It's right there, it's in the same place. Intro 13 shell is exactly the same place. This is the output of a code in physics. So it computes some energy, some things, and I would like to extract some data from there. So the file is big, so let's see how big it is. 4.1 megabytes. Doesn't look too big, but for a text file, for a human to read this is a pain. Let's see how big actually it is in terms of lines. So it has 92,000 lines. So it's again not something that you want to read one by one.
What's number C?
Word counter. This is counting the number of words. Actually, number of words, not the number of lines, number of words, number of characters, but I'm interested in the first. So my point is, this is a big file. This is a big file. For a human to read, this is a big file. And I was showing you here that this, well, this is from a code, and this is doing some output, and some atoms, and some more atoms, and some blah, 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 blah. Let's just go for it. So I would like to extract, for example, a special piece of line that I would like. So for that, there are a couple of commands that are really useful for extracting quickly data out of those big text files. One is grep, and time step, for example, from this output. So this is what I'm doing. I'm trying to extract all the lines that contains those two words together, like that. And now we'll get something like this. So, did it right?
So it brings all the lines that have time step.
Yes. Let me see why I'm getting more than that. Oh yeah, all the lines that contains the word. Look, and this one is there, time step. Here is time step, time step, time step. All those lines that time step somehow in my text. So this is one way to extract something. So
I can see the line.
the command line was this. Time step. Extracting just that. And there are ways, and maybe I will do, yeah, we'll do that. So imagine that you want to use that as a tag, and you can extract the lines that are on top of that, below that. You can do things with that. I will show you that. So imagine that you have a lot of people, and you can extract just female. So if there is a tag that it says female, then you can extract that somehow in a big text file. I can grab and get all those lines that contain that information. So you saw that you get a lot of lines here, but with some extra things. So now you can start doing more things to filter more what you want to get is with this. This symbol indicates everything that starts with. I would like to get this line, but I don't want to get this line. The difference between this line and this line is that there is something else after this, before this, that I don't like. So I will extract something that starts with something, have some number of spaces in front of it, and time step. The trick for doing this is something like this. So this symbol is for starting. This symbol is to encapsulate the character space. And this symbol is to indicate that in this, what is called a regular expression, I am happy to see 0 or more instances of this space. Actually, so if it has no space, I'm happy with that. It has 1 space, I'm happy with that. 2 space is happy. 100 space is happy. As soon as they only have spaces in front of that, I'm happy with this instruction. So I'm using this. I am getting just that. I'm filtering more than what I would like. So now I would like to get this with a few lines after that line to capture that, and 1 line before that. So I can extract portions of code after and before this instance of every single line that I use with that. So the before, the after is like this, and the before is like this. And you see what I am actually trying to capture. I'm capturing a very specific block of information that comes from time to time in this simulation code that's producing that over and over, and contains the information that I actually want. The time step, the energies, whatever, some technical information about what is happening in that simulation. And that's what I actually want to capture. So again, this is the command for doing that. And now, actually what I would like is, for example, for some analysis, I am just interested in the total energy of that system, not in the everything else. So I can pipe that to another graph to extract just the words items. So from that output, I am again extracting just 1 portion that I'm interested in, is this total energy. So now I can do something else here, and it's include a trick to get an average. It's like this. This is another command. This is actually a programming language that inherits some things from C.
How to pronounce that?
Awk. Nate, how you pronounce that? Awk. Awk. So, yeah. My English phonetics is not very good, so I need to rely on it. So I'm connecting this. So basically, what I'm trying to get is Awk will see this as 3 columns. 1 word, 2 words, 3 words, right? So, and they associate that with variables. So this will be $1, $2, this one $2, this one $3. So this I am making a sum of all the $3s, and I am collecting how many they are in this thing. And at the end, this is the It's getting, so we started extracting some lines. We got the pieces of code that we want. We extract again to get just with exactly the line that contains the data that I would like. And with this trick with awk, I am getting the average. It's super efficient. It's far more efficient than everything that you can do with Python for the practically the same thing, except if you tweak Python really good. What I mean by that is, in order to get something for several million lines and get something comparable in efficiency, I need to use the regular expression package module in Python, and I have to compile the regular expression before I execute this in order to be as fast as close to the speed of this. For a few thousand lines, you don't notice this, but probably have another exercise where I have for several million lines in a file. So you will see this for real, and you cannot do this with a normal Python code, let's say, except with tweaking and really knowing what you are doing to get this. But if you know awk, this is super efficient.
What is and means?
What?
And.
Ah, yes. Okay. This awk works in basically 2 steps. Whatever you want to happen before, there is a beginning. There is the normal block, what you want to happen for every single instance, for every single line, and what you want to happen at the end. You want to print this only at the end. And I want to avoid a division by 0. So this is just to prevent a division by 0, but so you can skip this. I know that this will appear. And I would like to print the value of the sum divided by n. So I would like just to see this when all the lines were processed and get me.
Probably have a start as well.
And they have a begin. It's begin. A begin block is actually. And I think I have another one with this begin block. Oh yeah. So now we will see something that I have here. This is called nano tree cover. So this is a file that is too big, so I compress it because it's a pain. So this is how you uncompress files in this format. This is a very useful, common format in Linux environments. The same as star.gc, as the zip files. You can also uncompress files in zip format, but they are not so frequently used in Unix environments. So this is what I'm extracting. You can see here, let me see, that I have a few folders. Let me see how we get this. You see the amount of lines that I have on each one of them. So a total of 7 million lines. And I would like to extract some pieces of information from those. Just to show you one, let's see, let me go back here. I am extracting a different piece of element. This is, I think, from a different execution, different code. This is the kind of information that I would like to extract. So if you see one of those, they have a lot of things happening. So you get a lot of those. And here you see, let me see if I can search for this. Yeah, I'm trying to extract something like this from this line. Instance of this. And there are many. There are many of those. So again, the first thing is I would like to extract this. Okay. And I'm extracting this just from one, just to show you how to extract from one, and later we will do it for all of them. So here I am getting that, and the next line, 9 lines after that one, and you get this. So it's this line plus 9 lines after. So
for text files.
what?
It's a binary file.
It's a binary file. You cannot do this. No.
You can't tell it to extract the text out.
Oh yeah, if it's a compressed file, you can do
There's
it.
a flag with group, I don't know what it is. But we'll where you
A binary file that is a compressed file, or what?
any type of binary file. It does the same thing as strings. So like strings.
Ah, okay.
Binary files,
Okay.
so capture the text out.
Okay, I got it. Yeah, if the binary file contains something that portions of strings, something that you can read, yeah, you can. So I would like to have also the before one. So I'm trying to get this. So this is the first part that I'm trying to get. Okay, just to show the same thing, but in a different way. In this kind of execution, there is this thing, time. And there is also this, when you extract just those that contain spaces at the very beginning. So there are a few things that you can do with this. Let me show you on the web what I'm talking about. We are right here. The kind of tricks that you can apply in regular expressions. So all those things that we were doing here are called regular expressions, and that's what grep does. So you can use this, for example, and you will use it to replace 0 or more instances of something that's before that. This one replaces just 1 instance or more. This one replaces characters, and you can put ranges here for a certain number, and you can encapsulate several characters together for the search. And this one means the beginning, and this one means the last, the end of the line. So, so I will show you here what I was doing. Okay, this one is good. This is exactly what I want to show. I am extracting one line with this set of characters, and I'm using the escape here in awk. You have to escape those characters out, and I am just getting the first here. With this, $0 is the whole line. 4 and 11 is 1, 2, 3, is this one, this column here, 4, 5, 4, 5, 6, 7, 8, 9, 10, 11, and this one. So this column. And here I'm extracting just the column number 4, column number 11 on this. Just those. And I can do this. So again, I am taking column number 11. I am multiplying that by a factor. Why? Because this is in some units in physics for energy, and I would like to convert it in a different unit. I don't remember if this is in Hartree, and I would like electron volts in different units. And in some areas, experimentalists used to have one kind of units, and other people use another kind of units. So you need to play between those. Yes.
Why don't you put by red?
I'm not grabbing. I am skipping the grab thing, and I'm directly using awk entirely. So I am going. I start with grab and introduce awk, and now I show you how you can do this kind of things without grab in a more purish awk way, because I'm moving into awk scripting. I will at the end of the day I will show you is an awk script that do this thing. So out of grab.
So this means
find that in all the lines, capture the number line, the 11, and associate that to a value n, and after convert that variable, change with a factor, because I would like to have that in Hartree. It's a different kind of units for energy in physics. So it's doing the conversion. It's doing the conversion for all those and extracting that. That is. And at the very end, this is what I would like to show you. Probably the code is there, but I will copy anyway. Being, let's see, the code is there. Maybe it's this one. No. I will create this. Okay. And I will. So let's see how that looks like. This is the code. And it's in the documentation, so you can see. I'm not expecting you to write that the right way. So as you mentioned, there is a begin block, there is a normal block, and this is an end block. Before we use the end block to get the average, because we need all those to capture. This is only happening with the begin block. So what I'm doing is getting the squares of the values that I'm getting here at the very beginning, and during the normal block, no, here and then here, the cubes and the end of that. So this one is a very minimal. I'm copying the wrong thing, but yeah, this is an example for sometimes. So to show you how those begin, main, and end block works. What I would like to do with my text is to have this code here. Let's see if I have it here. Oh yeah, there was, I think it's this one. How min max. Yeah, it's exactly this one. So let's have a look at this. Here, this is actually I have a, let's stay here, I think. This is the begin block where I'm extracting the data. So I'm capturing, so I set up some variables here at the very beginning, a minimal value, a maximal value. So I am set up crazy values at the very beginning just to capture the minimum and maximum. Here I'm extracting all the lines with this. And what I'm doing with them is this. I am trying to figure it out if the value is less than what I set up for the minimum. Otherwise, it will become the minimum, and they will change over and over and over until I get the extremes in that case. And at the very end, after this is processed, I will show you the minimum value, the maximum value, and the average value divided by the number of electrons in the system. Well, anyway, so if I execute this for one of those files for the gold nano 0,
I got the same one.
yeah, probably is this. It was, I have a bug there. It's my mistake, and I realized this, that I forgot this. I think this is. Yeah, I forgot to put the exclamation mark on the code and on this. So is reading that file. How big is that file? Remember, let's see again. This is 600,000 lines of text, and is doing this in what? I don't. You can put this at time. 1 second. 1 second. Yeah, it's taking 1 second to do this. So now let's see what happens if I interested to see all of them. So I put a star here. So now we have processing 7 million lines. Seconds. It's really difficult to beat this with any other language, let's say. You try to do it with MATLAB, maybe 6 months, or I don't know how many months you need to do this with MATLAB. You do it with Python, and yes, for sure it will not be 10 seconds. That's for sure. And there are some other things that you can do, and I will show you here that in some cases, you don't even want to uncompress those files. You can work with them directly compressed. And that's why I have this file here, distributions. So this is a text file. I don't know how big it is. Well, it's a few megabytes. But when you uncompress this, it will be something, again, a few million. It is compressed. So you can still use this. Let's see. If I remember how this is, I don't know if it was this direct. Right? So you can use CCAT and grep after that, so you don't never actually need to uncompress the file and work with that. But anyway, the exercise here is taking this file. If you want to uncompress it, it's okay. And the first thing is counting the number of let me see if I can show the exercise here. The exercise is this. Take this file. You want to uncompress it, it's okay. And count the number of lines in this file. You know, with WC, word counter. Count the number of columns, there are several ways of doing this. With this is one way with awk. Compute the sum. So up in the you scroll up and you will see the trick to compute the sum of that of those the first two columns actually, and compute the average. You go a little bit up, and then we'll give you a few minutes for you to explore a little bit with whatever of that you want to do. The average of the third column, and get two columns, print two columns. The first one, the sum, and after the second, the sum of the third, and 4 columns of the original columns of that file. So it's basically the same thing for something that has no text in the middle, but it's slightly easier as an exercise. But yeah.
Can you go back again? How you saw
Zcat.
Huh?
Without uncompressing
Yeah,
it,
without
Zcat.
So you can just type that into word count. And that will get you.
You can, yeah, exactly. That is something that you can exactly well. So if you don't want to uncompress it, this is one way. So you can play with this directly and
Then the last exercise for the day.
yes, this is the last exercise for today, and we are right in time for this. So I will give you, yeah, but it's if you want to ask me about this, it's okay. So this could be useful for some of you.
Do you want to give a brief overview of what the next class is?
Oh yeah, yeah.
Real brief.
Yeah, for the next 2 workshops. So again, probably you will send them the feedback, right? Online.
There's a survey, should be an email. Really, please repeat what I'm saying so that people want to fill it out. It's the only way we know we're doing something right or wrong. Or something Guillermo or I don't have to find out. They yell at us, you have to defend this. Something didn't like, something needs to change.
So I extend a little bit the questionnaire because something that I always would like to know is if the different topics are really interesting to you, or and it's always a compromise because some people see it's more interesting, for example, singularity and less into the conda thing, and some people, for example, this one has nothing to do with them. So from your answers, I will balance for the next year what things I will expand, which things I will shrink, and that helped me to figure it out on which parts we are getting success, on which parts are not reaching the audience properly, and it's always a balance. So please, if you receive that questionnaire for this workshop. And I changed this year based on what we knew the year 2018. Just for you to know, during the 2018, what I did was 4 days, from 9 to 4, and with more scattered set of topics. So people get lost. It was too much and it was too hard. So I changed that, so now we have 3 different workshops, and people can sign for one and not sign for the other, and not sign for the other. So they give them flexibility on what they will get when they are interested. Last year, I mentioned R, I mentioned Python, I mentioned Julia. So when you do that, you have to be very shallow in the explanation of those things. So this time I removed entirely everything related with parallel programming, OpenMP, OpenMPI, or things like that. No programming, and I removed R entirely. And I will create a different workshop next week for Python. And I basically create a new material. So I'm exploring what I have to do with this. For the Python next week, it will be the first day will be very introductory we will explore interactive Python execution, Python scripts, and Python programming. So a few small programs without entering scientific packages. And then the second day will be the scientific packages. By scientific packages, select 5. It will be NumPy, the basic Python package for numerical Python. SciPy for special functions, integration, this kind of more advanced computing. Pandas for data analysis. Matplotlib for creating plots, and Cython for converting Python code into C code and getting a performance that is really, really close to C code from a Python code. So how to get what is lost when you use Python is performance. It's really, really easy to program. It's really easy to work with Python, but it's slow. So Cython is the solution for that, which is one of the solutions for that. So that's what those are the 5 topics that I will focus for the next week, and then the next week, so the third week will be on machine learning. It will be very introductory. This is not a course. There will not be a class. I cannot do it on real hard code machine learning. I have to just show a few topics of interest, a little bit of clustering, a little bit of classification. I will try to escape a little bit of the traditional tutorials that you see online. So I'm creating material based on statistics, so some different databases and things like that, and starting to play with those and trying to see correlations, trying to use linear regression, exploring the relations between variables, exploring these different variables correlate with each other in some interesting ways, and what we can start exploring from data and start to getting insight into. And this is a lot of the things that people is doing right now for research in different areas, is try to bring this and trying to answer questions that were not answered before, and now we have those questions.
Those correlations in that you'll do on Wednesday or Tuesday?
It will be.
On the second day.
It will be. I think it's the second day. Well, one for the regression is the first thing, or one of the first things that I mentioned. So what I will do is, what I'm preparing for that is I'm taking data from OECD, from what it's called, I don't know if you are familiar with that, the Human Development Index. So it's an index that basically tries to capture for the different countries in the world how they perform in terms of mortality, child mortality, how the life expectancy, the gross, the GDP of the different countries, the size, the imbalance between income in different countries, the imbalance between gender in different countries. And all those things are captured in a lot of tables, and I'm trying to use that as an excuse for start showing you data, how some of those variables correlate to each other. So how GDP per capita correlates with life expectancy, with how inequality correlates with education, with some other things. So I am using that. This is something new that people use. Typically for these kind of things, they use some databases for housing from Boston. All the people do that. I don't want to do what other people do. So I'm using now this as an excuse for doing that. I'm plotting those different variables and trying to see visually what they represent, what they correlate. And from that, I motivate things. So I will go slow. I will not go very deep into very exotic things, but I will try to show the pathway of exploring data and getting getting insights, so trying to help you to make questions, and I'll have to how to answer those questions, try to answer those questions from the data, just from the data. That's
Next thing for Python, should people have a background already in programming, or?
the idea is the following. The idea is that the background that you need to work on Python next week is pretty much what you learn here. So and what you need for the third week is what you learn from the second week. So some people have attended this before, so they know, for example, for the next week, I will use Jupyter Notebook, and so I will use the Singularity image that I create to open the Qt console and start doing things on that. So if you don't know how to execute this, I will show them, the people, in 5 minutes, how to execute with Singularity, how to get the image, and how to pop up the environment from there. But I will not enter in details how what Singularity is, what it does for you, how other things are related to that. So it will be like a recipe. This is what you have to do. This is what you have to do. This is what you have to do. You see a window popping up. They will be like that. So that's why there is a rational sequence in the 3 workshops, and definitely if you will attend the third one, you need to understand Python, because you will learn that, because I will use, for example, for those regressions, I am importing data from an Excel file, and for doing that, I'm using pandas. And you don't know pandas, you don't know it. So they follow the sequence. They follow the sequence. So I will show what I would like to show in the third week, in the second week, in context. So that's the way I connect each piece to the next one.
Talk that if you guys did not sign up, and this includes the people remote, to come next week, and you want to, just email me. Although it's been closed, just email me. I'll still get you added. You guys all have the email address. You should have a survey, like I said, in the email. Please fill it out. It shouldn't take you more than 5 minutes. Other than that, we'll be sticking around for a little bit, but we'll close up shop. The YouTube videos, I do want to get uploaded, but we're actually having some issues with our account for YouTube, and I'm working with our identity management group to get that fixed, but it's not been fixed yet. So as soon as I get that, I'll email that out for people that are interested in it. And like Guillermo said, all the documentation stays on the web. We don't ever delete it. There's no instructions deleted. Training accounts will be deactivated tomorrow morning, maybe tonight. All right. But you have your own personal account. If you don't have one, you can sign up for it. Everything he showed you with the training accounts, other than being able to use a training queue, you can do with those accounts. And the standby queue will give you more than enough time to do stuff quickly. So you don't have to really worry about having the training queue.
Got a question. We need 2 different answers, so I was trying to sum the first column initially, just to see if it works. So that was this line right here.